Good evening, friends. Welcome to day two of the Six Sigma Masterclass Elite sessions. So, yesterday we started with understanding the traditional and the modern day definition of quality. So, while traditional definition focused only on the customer's interest, the modern day definition of quality focuses both on customer as well as the service provider or manufacturer's interest. And when we actually understood the modern day definition of quality, we also touch based on the cost of poor quality and cost of good quality, and also understood how cost of poor quality directly impacts the profitability of an organization. Then we looked at the various dimensions of the overall quality and also understood the evolution of quality over a period of time. And we also looked at some of the important quality terminologies like quality control and quality assurance. Then the second set was CAPA, corrective action and preventive action. In fact, there are three stages in CAPA: correction, corrective action, and preventive action. And then we looked at cause and effect. Then finally, we also looked at the three commonly used process improvement methodologies. Kaizen, these are the small and continuous process improvements which will be performed or which can be performed even by an individual employee who could even be at the ground level of an organization hierarchy. Then lean as a philosophy is all about creating perfect value to the customer through a process with zero waste. Then Six Sigma is a breakthrough process improvement methodology, which should ideally result in significant dollar savings for the practicing organization. And we also looked at how to, identify whether a project initiative is Kaizen or Lean or Six Sigma. So we need to consider causes and solution. Causes are known, solution is simple, then it will be Kaizen. Causes are known, solution is complex, then it will be Lean. Causes are unknown, solution is simple. We'll ask an expert. Causes are unknown, solution is also complex. That's when we will call that initiative as Six Sigma. So through this, we could understand why Lean would focus on attacking the known causes for a business problem. Six Sigma would focus on exploring the unknown causes, making it known, and finally attacking the same with relevant solutions. So that is why all these Six Sigma project initiatives will also be referred as Lean Six Sigma projects. Then, since Lean is an integral part of our Six Sigma journey, we started with the basics of Lean, right? So, we understood about how Lean as a philosophy evolved in Japan, specifically in Toyota production system. So, Lean is all about identifying the ways or the non-value added activities in a process chain so that we will be able to eliminate the same and execute the process within a shorter time frame. So as I told yesterday, the main objective when we perform a lean project is to reduce the overall time taken to work on a process, right? And we also looked at what exactly is a non-value added activity. So these are the activities that doesn't add any value to the output produced by the process in terms of shape, size, or quality. So let us continue with our discussions regarding the basics of lean. As I told you yesterday, so lean as a concept will be dealt extensively as part of your yellow belt curriculum, but then the green belt and black belt curriculum, we will be focusing more on the Six Sigma tools and techniques, specifically the statistical tools and techniques. But since lean is an integral part of our Six Sigma journey, we will quickly touch base on the lean concepts and then formally get introduced to the Six Sigma. So let me just share my screen. Right, so let me also put today's date, which is 8th of Jan. Fine. So the waste, as we would call, is of three forms. What are the three forms of waste? So since lean as a concept originated in Japan, so all these forms of waste carry some Japanese terms. So Muda is typically the waste that you would identify in a process chain. So Muda is the typical non-value added activities that we would identify in our process. And then Mura is the variability or inconsistency, right? So if you are going to execute the process with lots of inconsistencies and variability, obviously the output delivered by the process will also be not consistent. So that will also be inconsistent and will contain lots of variation, right? So when we execute the process in different ways, will the output be the same? So output also will vary accordingly, right? So that's why I told you. Yesterday, we also looked at the coffee preparation example, right? So if you have a formula to prepare the coffee, and if you are going to follow that standard approach, so irrespective of whoever is going to prepare the coffee, the taste of the coffee will be pretty much unique, right? So it will be pretty much standard or consistent, right, in different outlets of that restaurant, right? So it's not as if the same person is preparing coffee in all these outlets, right? So it will be different people who would be preparing coffee in all these outlets. But how come the taste is unique in that particular restaurant outlet? Because they follow a particular standard procedure, so, right? So that is what we would call as a secret formula, right? So when the standard procedure is being adopted, so automatically the output delivered by that process will also be consistent. But then, if people are going to execute the process as per their own wish, then obviously the output delivered by that process also will contain a lot of variability or inconsistency, and that is what we would call as Mura form of waste. So when we have lot of variability or inconsistency observed in the output, that will also contribute to the defect, right? So the customer would want the output, right, to measure, say, between this centimeter to this centimeter, right? So if the customer has given the specification for the length of a pen, so the customer would have given the specification that the length of the pen should measure somewhere between say 9.9 centimeters to 10.1 centimeters. But then if the variability is going to be huge, right? So the length might actually fall below 9.1 centimeters or can be above 10.1 or 9.9 centimeters or can be above 10.1 centimeter. In that case, the customer would reject that unit product as a waste, as a non-conformance, or as a defect, right? So the Mura form of waste will also contribute to defect, which is a type of this Muda waste, right? So which defect, as you will know in a short while, is one of the seven plus one types of waste, right? We will see all these things in the coming section. But for now, we need to understand whenever we experience Mura form of waste, it would result in defect, which is a Muda type of waste, right? And then the third form of waste is Muri. So what is Muri? In Japanese, Muri means overburden or stress. Suppose you are going to overburden a particular employee with lots of work, right? That employee is working day in and day out. Or if it is a manufacturing scenario or overburdening a particular machinery with lots of work, right? So you are running that machine day in and day out. So what will happen? So the person will get stressed out and will contribute to lot of errors, right? The defects will happen automatically. Similarly, the machine will depreciate quickly and there will be a deterioration in the performance. So again, right, Muri form of waste will result in defect, which is a Muda type of waste. So whatever be the form of waste, ultimately the result would be in the form of a defect, right, which will be a Muda type of waste. But then we need to understand that these are the three forms of waste. Muda, which is the non-value added activities that you would observe in a process chain. And then Mura is the variability or inconsistency that we would observe while executing the process, which would result in inconsistent output delivered by that process. And Muri is all about overburden or stress, right, experienced by an employee or by a missionary, right? Similarly, the non-value added activities are of two types. One is called the pure non-value added activity, which we can identify in the core production process. So if you look at an organization, there will always be a core production process, right, which will be producing the output which the organization would be marketing, correct? Say, for example, if the organization is manufacturing mobile phone, So there will be a core production process which would be engaged in manufacturing that mobile phone, right? But there will be support functions which will be supporting this core production process. So there will be HR function, there will be a finance function, there will be an admin function, there will be a training function, there will be a quality function. So all these support functions will be supporting the core production process, correct? So, but then we need to understand the activities performed by these support functions may not have a direct impact on the output that is produced by the core production team. So here in the mobile manufacturing company, as I told you, the core production team would be manufacturing mobile phones, right? So the activities that are performed by the support functions like HR or quality or admin or finance may not have a direct impact on the output that is produced by the core production team, that is the mobile phone, right? But these activities are very much important for the core production process to function effectively and efficiently. So that is why all these activities that are performed by the support functions, even though they may come under the list of non-value added activities, but these are essential non-value added activities or value enablers. So NVAs are of two types. One is the pure NVA that we can easily identify in the core production process, and the other one is the essential NVA, which are typically the activities performed by the support functions. So when you look at the NVA definition, obviously the activities performed by the support functions will actually come within that particular purview. But then we need to understand that these activities performed by the support functions are very much essential for the core production process to function efficiently and effectively, and hence the activities performed by these support functions will be called as essential NVAs or value enablers. So in a lean project, what is that we will try to do? Obviously, we will try to maximize the value added activities, but then minimize the essential non-value added activities or value enablers. That's why you would find couple of HR executives supporting a production team of 100 executives. So you'll not have the support function executives in 1:1 ratio, right? So if you have 100 executives in the core production team, obviously we'll have only couple of HR executives or couple of quality executives supporting all these 100 core production executives, right? So that is what it is. So we need to look at minimizing this essential non-value added activities or value enablers. And then, of course, we need to look at eliminating the pure non-value added activities, right? So these are the three main objectives that we will try to accomplish when we work on a lean project. Obviously, if you work on these three objectives, we will be able to reduce the time taken to execute that process because we'll be making the process lean by eliminating all these pure non-value added activities. So we will be able to execute that process within a shorter time frame. Right. So whenever we set up a lean organization, so we need to be aware of these five lean principles, which are very, very important, right? So if you want to set up a lean organization, so we need to uh, adhere to these five principles of lean. So let us look at all these five principles in detail. So the first principle, as we would have seen yesterday, uh, quality definition started with understanding and fulfilling the customer requirements. Similarly, if you look at lean, we need to first and foremost understand the value expected by the customer. So yesterday itself we saw, right, when we discussed about the lean as a process improvement methodology. So we looked at that phrase, lean is all about creating a perfect value to the customer through a process with zero waste. So, in order to create that perfect value to the customer, we need to first understand what is the value expected by the customer. So, first and foremost, we need to understand the value expected by the customer. So, what is this? So, we need to understand the output for which the customer is willing to pay for, right? The customer wants elephant and is willing to pay for an elephant. We should not be producing a cat, because customer is not going to pay for the cat, right? Customer is willing to pay only for the elephant. So elephant is the output or the value expected by the customer, not the cat. Cat is also an output, but cat is not the value expected by the customer. So it's important for us to understand the value expected by the customer so that we will be able to kind of orient our processes towards achieving that objective or creating that value as expected by the customer. So the next principle is map the value stream. So here is where we will be identifying the list of activities. So when we identify the list of activities, we will not probe whether a particular activity is a value added activity or a non-value added activity. We will simply list down all these activities that are required to be executed in order to deliver the value expected by the customer. So that is what is map the value stream. So when I say map the value stream, it's all about identifying the list of activities which could be both value added as well as non-value added that are required to be performed in order to deliver the value expected by the customer. Because the value or the output expected by the customer cannot produce out of thin air. So you need to have list of activities to be executed in our process. So what are the list of activities that we are supposed to execute in our process is something that we need to identify, right? That is what we do in map the value stream. So if you look at this A, B, and C, so A, B, and C are the three activities. But if you look at all these three activities put together, they will form a process. So process is combination of multiple activities, right? So when we have multiple activities being executed in order to produce the defined output, then the collection of these multiple activities will form a process, right? So that is what we will try to identify the list of activities that we are supposed to perform in our process chain in order to deliver the value expected by the customer. And the third one is established flow, right? So once we have identified the activities that are supposed to be executed in order to deliver the value expected by the customer, we need to provide directions for these activities to flow in a process chain without any bottleneck or hindrance. So which of these activities that I have identified should be arranged in a series? All these terminologies you need to understand. What do you mean by series? Yesterday itself, we briefly discussed on this. Series is nothing but executing the activities one after another. So here A, B, and C are arranged in a series, right? Because B as an activity cannot be performed unless and until A completes his part of the work. C as an activity cannot start unless and until B completes his part of the work. So there will be a dependency on the upstream activity when we have the activities arranged in a series. Yesterday itself we saw what is upstream, midstream, and downstream. So A will be the upstream activity for both B and C. B will be the midstream activity for both A and C will be the downstream activity for both A and B. So which of these activities that I have identified needs to be arranged in a series, that is one after another, and which of these activities can be executed in parallel? So along with A, probably we can also execute the activity D. In that case, D will be performed in parallel to A. Or there could be certain activity which can be executed in parallel to this activity C. So we will arrange the process chain in such a way that we will identify which of these activities are to be arranged in a series and which of these activities are to be executed in parallel, right? And once we arrange all these activities in a process chain, the main idea is to ensure that the process flows like a stream of river. So there should not be any hindrance, right? There should not be any bottleneck or there should not be any stoppages in the process flow, right? So the process should flow in a seamless manner. So if A starts, performing his part of the work because A is the first activity that we will perform in this process, right? So A starts working on his part of the work. So it should smoothly, get transition to B and B will complete and then transition it to C, and it will keep going like this for each and every transaction, right? So there should not be any bottleneck. So we should not face any scenario where B is required to follow with A, or C is required to follow with A, and so on, right? Or B is required to send reminders. So we should not have that kind of a scenario. So it should flow in a smooth manner, right, without any bottlenecks or stoppages. So that is the basic idea. Whether that is happening or not is a different question. But when we arrange the activities in a process chain, the main intention is to ensure that the activities flow in the process like a stream of river without any bottleneck, without any stoppage. And that is what we would try to accomplish in established flow. And then the fourth principle is implement pull, right? Implement pull is a very, very important principle which would help us to eliminate the waiting time waste that would be experienced by the downstream activity. So as I told you, there is a dependency for B on A, right? So unless and until A completes his part of the work, B will not have anything else to do, correct? Because B is the immediate downstream activity for A. Similarly, unless and until B completes his part of the work, C will not have anything else to do because C is the immediate downstream activity for B, right? So when it comes to implement pull, the downstream activity will have to signal a demand to its respective upstream counterpart to complete his part of the work as early as possible so that the downstream activity doesn't face any idle time waste. So yesterday itself, we briefly discussed about this when we actually looked at the revamped Toyota production system. So I told you that there has to be a proper coordination of work between all these workstations, right? So as and when workstation 2 is about to complete his part of the work, so workstation 2 will have to signal a demand to workstation 1, right? The signal should be like, I am on the verge of completing my current activity. So please complete your current activity and send the vehicle as early as possible to me, right? So unless and until workstation 2 is going to signal a demand to workstation 1 would never know whether workstation 2 has already completed his part of the work or is on the verge of completing his part of the work, right? So workstation 1 might actually take his own time while in executing his part of the activity, right? So that would only delay completion of the activity by workstation 1, and then we could face a scenario where the workstation 2 would have already completed his part of the work and would be sitting idle, waiting for the car to move in from workstation 1 to workstation 2. So this should never happen in a process chain. So that is where this implement pull comes into the picture, right? So the downstream activity will have to signal a demand to its respective upstream counterpart. So here, B as the immediate downstream activity for A need to signal a demand to A. So as and when B is nearing completion of its current activity, it has to signal a demand to A that I am on the verge of completing my current activity. Please provide your output at the earliest. So unless and until this demand is made by B to A will be taking his own time in delivering the output to B, right? And which might actually result in the waiting time or the idle time waste for B. Similarly, C as an immediate downstream process or downstream activity for B will have to signal implement pull or will have to signal a demand to B asking B to provide its output as early as possible because C is on the verge of completing its current activity, right? So unless and until this demand is placed, B will be thinking that C is not yet ready and will be taking his own time to deliver the output to C, and that would result in the idle time or waiting time waste for C, which should never happen. So as I told you, the activities in the process chain should flow seamlessly without any bottleneck. So we should not face any scenario where the downstream activities are sitting idle, waiting for the upstream activity to provide the output, which will be an input for the downstream activity. So A's output will be B's input. B's output will be C's input, right? When we have the activities arranged in a series, like this, one after another, we can very well understand. So A's output will be B's input, B's output will be C's input. So unless and until A completes his part of the work, B will not have anything to do. Unless and until B completes his part of the work, C will not have anything to do. So implement pull is very, very, very essential. So this would actually help us to ensure that the activities in the process chain flow seamlessly without any bottleneck, and we don't face any kind of idle time or waiting time waste with respect to the downstream activities, right? So there are various pull mechanisms that would be enforced by an organization to make its workforce function more effectively and efficiently. So what are the various pull mechanisms that we can witness in an organization which would actually motivate the employees to perform at their best? So obviously the incentives, right, that the organizations would announce is kind of a pull mechanism which would attract the employees to function more efficiently and effectively. The promotions, the variable pays, or simply the targets, right? So even if your customer hasn't provided you with any performance target, the leadership would definitely provide you with some performance target. So imagine a scenario where there is no performance target at all for you to achieve. Will you be motivated to function efficiently? Definitely not. When there is no target for you to achieve, obviously you'll be, executing your work as per your own wish. You'll be taking your own time in executing the work. You'll not be bothered about the quality production. And obviously, we cannot expect quality output from this team, right? So implement pull is very, very important. So this is the kind of a pull mechanism which would attract the employees to function more efficiently in an organization. And these are the pull mechanisms that the organizations would deploy in order to make the workforce function more efficiently. The annual appraisal ratings, the promotions, the incentives, the variable pays, the targets, all these are the pull mechanism. So what is opposite to pull? Opposite to pull is push. Push is forcing someone to perform, right? So push is literally threatening the employee. So in case of the employees in an organization, the push mechanism, if it is adopted by an organization leadership, it's all about threatening the employee that if you don't perform, you will be kicked out of the organization, right? So this is like a stick approach, whereas pull is like a carrot approach. So pull is all about attracting the employees to function more efficiently, whereas push is all about threatening the employees to function efficiently. Otherwise, there is a threat that the employees would be kicked out of the organization. So which one is better? Obviously, the pull is better. But then if pull doesn't work, then people may resort to that push mechanism. But we will first try out the pull mechanism. So implement pull in case of lean is all about the downstream activity signaling a demand to its respective upstream counterpart to produce its output and deliver it quickly so that the downstream activities doesn't face any idle time or waiting time waste, right? And as I told you, if implement pull is not exercised, it would result in the waiting time or the idle time waste for the downstream activity. And then finally, we have work to perfection.
Sir, I
And
have
work
a
to,
question
yeah,
here.
yeah,
Sir, in implement pull, you mentioned that if there has to be a smooth process, there should be no reminder or follow-ups. But
yeah.
then in implement pull, you're saying that the B will have to
Hmm.
send a reminder to A
No,
that
no, no, not reminder. It's just a signal. We're not, the B is not going to type out any reminder and send it to A, right? So it's just a signal. So it can be even a signal by hand or whatever means, right? So it need not be something that is written and then, formally sent to A. That will not happen. That is not the
but
thing that I
even if it
mentioned.
is a signal that
Yeah.
that is an activity done by B to A, so that shouldn't be there in a smooth
No, no, no.
process.
The thing is, when I say signal, so there has to be some kind of a uh, what to say, there has to be some kind of a indication by the downstream activity. Say for example, workstation 2 is on the verge of completing its current activity. So it has to make workstation 1 realize that it is on the verge of completing its current activity so that workstation 1 would be prepared to complete its part of the work, right? Otherwise, what will happen if workstation 2, doesn't really signal it in any way, right? Workstation 1 will be thinking that workstation 2 is not yet ready to receive the next assignment, right? So workstation 1 will be taking its own time in completing his part of the work. When I say signal, it's not something like a practical signal. It is not like, waving your hand or whatever it is, right? So it is about, giving an indication to the upstream activity that I am on the verge of completing my current assignment. So please, perform your activity as early as possible so that I am not required to sit idle. So that is the basic idea of implement. It's just an indication. It need not be typed out reminders or whatever, right? So that cannot happen for each and every transaction, right? It's just an indication that is kind of indicated by the downstream activity to the upstream activity. So even in your own processes, so how will you know that the downstream activity is ready to accept your work? So they would be, kind of, do giving some indication to you, right? So in the case of the processes being executed in the same floor, right? So we can easily find out. So that is why, if the activities are kind of split between two different locations, so we see, part of the activities will be performed by the onshore team. Part of the activities will be performed by the offshore team, which is quite common nowadays. So when the handoff is going to take place between two different locations, then it's going to be very, very difficult for you to exercise this implement pull. So you won't even know whether the downstream activity who might be located at onshore, people sitting in offshore, might not even know whether the people who are actually sitting at onshore is ready to accept the next transaction, right? So you'll anyway keep dumping all these transactions to them without even, understanding whether they are prepared to accept the next transaction. So that is actually better rather than the downstream activity having to sit idle. So in most of the scenarios, if you see, the other way around will happen. That is, the upstream activity would have completed the work and will push the output to the downstream activity. Downstream activity, will have the work getting piled up, right? But then there shouldn't be a scenario where the downstream activity is made to wait for the output from the upstream activity and they are forced to sit idle and wait for that output to be delivered, right? So that kind of a situation should never happen. So when I say indication, it doesn't mean that we are going to kind of send a reminder or perform a follow-up activity, etc. It's not like that. So just even when you hurriedly complete something or you start packing something or when you signal that work is getting completed, that itself is an indication. So that can be easily followed if the entire team is going to sit in one place. That's what I was telling this example, right? So the team is split between offshore and onshore, then it becomes very difficult because nowadays we find part of the activities are executed at offshore and part of the activities are executed at onshore, and it becomes very difficult. It's not like 50%, the continuous activities will not be done. So one or two activities here, third activity, fourth activity at onshore, and then the fifth activity at offshore, then the sixth, seventh, and eighth activities at onshore. So like this, it will crisscross between offshore and onshore. Then it becomes all the more difficult to actually exercise this implement pull because the people who are actually working right at offshore and onshore will not even know whether the other party is ready to accept their work.
Got
So
it.
I would
Thank
like to
Yeah,
say, so I would like to share some
yeah,
examples
yeah,
of this, no?
yeah.
What this basically the company are using for the Gantt chart, no?
Hmm.
Gantt chart to track the activity. They know that we have to complete this task in
Exactly.
day one, and after that we have to send the aircraft to the painting. After that, another task uh, uh, has to be done, no?
Exactly. That's what I told you, right? So keeping a target itself is like implement pull. It need not be kind of a reminder being sent. So the Gantt chart example that you quoted is an excellent example, sir, wherein you would plan for all these activities to be completed within a specific time frame, right? So that itself would act as an implement pull. So each party will know within what time frame they are supposed to complete their activities, right? So that is another implement pull mechanism that we can exercise.
Because sending reminder is considered wasted
Yeah.
activity.
No,
Yes.
we are not looking at sending reminders again,
Yeah.
right?
Yes.
So that is considered as a waste. Exactly. So that should not be done. So it's not, see, if you have thousands of transactions to be processed, for each and every transaction, you cannot send reminders, right? The downstream activities will have that as one of the work then. So which is an absolute NVA, right? So that is not the thing. When I say implement pull, it's some kind of an indication, as the other participant rightly pointed out. It can also be through this, time frame that is given in a Gantt chart, right? So that Gantt chart will act as an indicator. So the upstream activities will know, right, within what time frame they are supposed to complete the current work, so that the downstream activity is not kept waiting for it. So it's kind of an indication. That's it, right? You even pack things. You hurriedly pack things. You'll know that the downstream activity is about to complete its current work. So that is an indication given by the downstream activity to the upstream activity that I am on the verge of completing the work. The
I
final
guess,
principle. Yeah.
I guess one more example that
Yeah.
will clarify this. Uh, there is one more option or maybe feature within Teams application that's called Loop,
Mm.
and there we can assign the task to different guys. And whenever
Correct.
the task is completed, they will just tick it in the way that it is completed. So everyone
Correct.
will get to know the task is completed.
Exactly. That is what you do in
So yeah,
agile work,
that's
right?
right.
So
That's right.
so where things are being done live by all the
Yeah,
parties concerned.
exactly.
So we
When
will know.
when we have multiple stakeholders for particular activities, we can utilize that.
Correct. Exactly. Absolutely right. Fine. So the final one is work to perfection. So work to perfection is the stage where we will try to identify the non-value added activities in the process chain and look at eliminating the same from the process, right? So these are the 5 principles of lean. So which are like your 5 pillars based on which the lean organization would be set up, right? So if you want to set up a lean organization, we need to adhere to these 5 principles of lean. Very important. Fine. So we have been discussing about waste, non-valued activities, etc., right? But then we need to understand the types of waste that we can identify in a process chain. So there are 7+1 types of waste that we can easily identify in our process, right? So what are these 7+1 types of waste? Why it is first of all called as 7+1 types of waste? Because the +1 waste, the eighth waste, got added to this list recently. So we had only 7 types of waste when lean got introduced, but the eighth waste got added to the list recently. So in order to recognize all those ways that were very much in place when lean was introduced, we call this as 7+1 types of waste. So the 7 types of waste can be listed down if you can remember the acronym called DIME-WAT, right? So DIME-WAT is the acronym. If you can remember it, you will be able to list down all the 7 types of waste. So the first one, D stands for defects, and I stands for inventory. M stands for motion. E stands for extra processing. W stands for waiting. O stands for overproduction. And T stands for transportation. So these are the 7 types of waste that existed when lean was actually introduced, right? Some people would remember the acronym called TEAMWOOD and then list down all the 7 types of waste. I'm quite comfortable with this acronym called DIME-WAT. So we can list down all the 7 types of waste without missing out anything. So defects, inventory, motion, extra processing, waiting, overproduction, and transportation. Now let us look at all these 7 types of waste in detail. So the first one, defects. Defects is quite self-explanatory. So when we, commit an error, obviously it would result in a rework or correction. So yesterday itself we discussed this at length, that rework or correction is a wasteful activity, right? It will add up to your cost of poor quality as well. So defect is a primary waste that we can easily identify in our processes. And then we have inventory. So what is this inventory type of waste? In a manufacturing scenario, this inventory type of waste is nothing but producing excessive goods more than the current demand that is existing for it, right? So the current demand is only for X number of items, but you have produced 2 into X number of items. So the excessive production, you cannot just like that throw it somewhere, right? You need to preserve it for selling it in the future. So you need to look out for a godown, you need to look out for a warehouse to keep all these items. It could be finished goods, it could be raw materials, right? So when you are paying excessive rent, right, for storing all these, excessive production of goods, that will typically become inventory type of waste. So it can happen the other way around also. So you are facing a huge demand for your product, right, in the market. There is a huge demand for your product in the market, but you are not able to supply, catering to the demand, right? So here you would be facing revenue loss, right? So you are having demand for X number of items, but you are able to supply only 0.5 into X number of items. So you're not able to supply catering to the demand existing in the market, just like the Toyota company, right, during the early part of their production. So when you're not able to supply catering to the demand, the revenue loss is also termed as an inventory waste. So the inventory waste can either be a cost enhancement, which will happen when you pay rent for storing all those excessive production in the godown or warehouse. And in fact, if you are going to preserve all these food items, then the cost that you would incur for preserving these food items is going to be huge, right? You would probably need refrigeration to be done for preserving all these food items, right? So food items you cannot produce in excess, right? It will be very, very costly, right? Preserving all these food items. And even if you are going to preserve all these food items in a sophisticated environment, the food items will have a limited shelf life. So you will not be able to store all these food items forever. So it will have a limited shelf life. We need to understand that. So in that case, the inventory waste could be very, very high. So sometimes what will happen, because you have produced in excess and the shelf life is also getting over, so you might have to throw that food item as a waste. So you cannot use it any longer, right? So you need to throw that entire food item as a waste. So it will not only be the cost of preserving all these food items, but the entire food item itself will be a waste here, right? So we need to be very, very careful. So inventory type of waste is something that we should not experience at all, because we should not end up, producing excess of what is required by the people, willing to buy your product in the market. So we need to plan for the demand, right? We need to forecast our demand, and we need to plan our production accordingly in order to eliminate this inventory type of waste. But then if you are working in an IT process, what could be an inventory waste? So we might have all these, software applications stored in a server space, right? So some of the software applications would have become redundant. That means some new version of that application would have come in. So you would have started using that newer version of that application. So the older version, right, would have become totally redundant. So that is not used at all. But you wouldn't have actually removed it from the servers, right? It would still, occupy the server space. So the server space, as you all know, doesn't come free of cost. So you need to pay huge rent for the server space. So all those redundant softwares that you still have in the server space, for which we are paying an exorbitant rent, is typically the inventory type of waste that you would experience in a IT setup, right? And then we have motion. What is this motion waste? So motion waste is nothing but excessive body movements. So yesterday itself we discussed briefly about this. So when the work group, right, the Toyota production system prior to the modernization, so where we had the cars, stationary in the shop floor, and the workforce would move from one car to another without even knowing whether they have already attended to a particular car or not. So this I told you that is an example for motion waste, right? So motion waste is typically excessive body movements. Say, for example, you are seated on the third floor and the printer is on the ground floor. As part of your routine work, you are required to take printouts every half an hour. So what you will do, you will keep climbing up and down every half an hour to collect the printouts, right? So this is typically a motion waste. So if only the printer was in some corner, the third floor itself, then you wouldn't have to probably climb up and down to collect the printouts, right? This motion waste can be minimized to a greater extent. Similarly, when you are working in an IT park, right, you might have your offices in different buildings in an IT park. This is quite common, right? So you're working in an IT company, right? So you will have offices in multiple buildings in that IT park, within that IT park. So there is a meeting happening in some other building. So what you will do, you will not, take any vehicle for attending the meeting, right? So you will climb down and then you'll probably walk the distance, reach the other building, and then again, go to the place where the meeting is conducted. So all these, excessive body movements that you would experience is nothing but a motion waste. So if possible, if you are able to attend the meeting through a call or through a video call, so that would help us to eliminate this motion waste, right? So motion waste is nothing but excessive body movements. And then we have extra processing and overproduction. So both these ways may actually sound similar, but they are drastically different. So what is extra processing waste? So extra processing is all about performing an additional activity that doesn't add any value to the output, right? Whereas overproduction is all about producing in excess of the current demand for which the customer is not willing to pay for. So the customer has ordered for 100 pens, but the manufacturer has produced 110 pens. For the additional 10 pens, the customer is not going to pay for it, right? So it is manufacturer's fault that he has produced 110 pens. So the customer is not going to pay for it, then it will become overproduction waste. So extra processing is always looked at from a process or an activity perspective. Overproduction is always looked at from the output perspective. So in a household, there are only 3 people, but you have prepared food for 5 people. So the excessive food that you have prepared, right, needs to be uh, given free of cost or has to be thrown as a waste, right? So that is typically the overproduction waste. But if you are able to realize value at a later date for that excessive production, then it will not become overproduction waste. So the overproduction waste will be when you are not able to realize value for that excessive production. Clear? So if it is like made to order, as I told you, a customer has given an order for 100 units of pen, but the manufacturer has produced 110 units. For the additional 10 units that the manufacturer has produced, the customer is not willing to pay for. Then it becomes overproduction waste. But if the manufacturer is able to preserve all those additional units of pen and is able to sell that to some other customer and realize its value, then it will not become overproduction waste. So this is the thin line between the overproduction waste and the inventory waste. Inventory is something where we can actually realize its value at a later point of time, right? So here the inventory waste is typically the storage cost that we would incur. Or if you are going to lose out on revenue because of lesser supply, that is what we would call as an inventory waste. But in case of overproduction, the excessive production that we would come up with we will not be able to realize any value for it, right? We will not get any money for it. Then in that case, it will become overproduction waste. So in case of extra processing, as I told you, so we can list down a lot of activities that we would execute in our process, which can be termed as extra processing waste, like the follow-up activity I told you. The reminder, sending reminders is an extra processing waste. Rework is another extra processing waste. In fact, any English word starting with RE, any verb in English starting with RE will be termed as a waste as far as lean is concerned. So recheck, rework, right? Reminder. So any verb or action in English starting with RE will be termed as a waste. Similarly, yesterday also we looked at this example, right? Attending all these redundant meetings. So you would not be knowing why you are being called for this particular meeting. So you'll not even know about the agenda. You will not know what to contribute. You'll be sitting idle in that meeting without having anything else to do, right? Since it is an in-person meeting, you'll not be able to do some other work. So you just need to sit idle for that 1 hour period without knowing what to do. So it's typically an extra processing waste, right? Or preparing multiple reports with the same content, extra processing waste, right? So these kind of extra processing waste we can easily identify in our own processes. In fact, the quality check that we do, some people would term that as an extra processing waste because no customer would pay for the quality check or the quality inspection. We need to understand that quality inspection is done internally in order to ensure that the customers receive error-free output. That is the objective. So it is an internal arrangement by the service provider or by the manufacturer. The customer would not actually provide any kind of support for this quality inspection activity. So it is done for our own benefit. So in that case, so anything for which the customer is not willing to pay for will not be called as a value, right? So from that perspective, you see even the quality inspection activity that one would perform can be termed as an extra processing waste because we ideally need to perform all these activities right first time. So we should always look at how to identify waste. We should always look at how a process can be executed in an ideal manner, right? So that ideal process would be very much available in your process document. Whether we are executing that process in an ideal manner is a question mark. So that ideal process also can be further improved. There is absolutely, no doubt about that. But whether we are executing the process as per what is depicted in the process document itself is a big question, right? So we might have added some more activities inadvertently while executing the process. So in that case, all those additional activities that we would perform would be typically the non-value added activities. So these activities may not add any value. So if you are going to create this as-is process flow, right, depicting the process as it is being performed in the shop floor, and if you are going to have the ideal process flow, which is the depiction of the process as detailed in the process document. So comparing these two itself, we will be able to clearly find out what are the additional activities that I am performing over a period of time inadvertently, right? It is not done with purpose. So inadvertently, I might be, executing certain additional activities. So sending reminders might have become an activity, might have become a legitimate activity over a period of time. So the person would be thinking that sending reminder is a legitimate activity, but sending reminder will not be part of the ideal process flow that would be there, part of your process document. So we need to understand that. So extra processing ways or the additional activities that we would perform, which is not going to add any value to the output delivered by the process, can be easily identified when we compare the as-is process flow. That is the process as it is being executed in the shop floor when it is compared with the ideal process flow, which would be part of your process document, right? And in between, we have this waiting time waste. So as I told you, whenever we have multiple handovers taking place, obviously you'll experience this waiting time waste unless and until there is a proper coordination between all these activities arranged in a series. So, so how to eliminate this waiting time waste? One, technique is to implement pull, which we all know. So we need to have proper coordination, and the downstream activities will have to signal a demand to its respective upstream counterpart to deliver its output. So through this, we will be able to reduce or look at eliminating this waiting time waste. Otherwise, whenever we have the handovers taking place, so A to B is one handover here, B to C is another handover. So like this, if you have series of activities being done by multiple executives, there will be multiple handovers in that process. And at each stage, you will be able to experience this waiting time waste, right? So we can easily identify this waiting time waste. And more so, when the process is completely split between two different locations. As I told you, part of the activities are done at offshore, part of the activities are done at onshore. And it is not like continuous activities are done at offshore and onshore. So it might be crisscrossing between offshore and onshore. So obviously the handover is going to be very, very tough, and the waiting time waste is bound to be there, right? So waiting time will happen whenever we have multiple handovers taking place in a process chain. So that is why when people try to automate, what they will do, they will try to combine multiple activities into one single automated activity. So there could be an opportunity to automate, right, this process wherein we can combine all the three activities A, B, and C into one single activity, right? By automating, we would be able to straight away eliminate the possible waiting time waste between A and B and also between A and C, right? So it can be completely eliminated. So that is what, people would try to do when they actually automate. So another way of, reducing this waiting time waste is to have a one piece flow rather than, executing a batch processing. So what do you mean by batch processing and what do you mean by one piece flow? Say, for example, we have these three activities A, B, and C arranged in a series, that is one after another. And there are something like 20 transactions that needs to be executed in a single batch. So if it is going to be a batch processing, what will happen? A will perform his part of the activity for all these 20 transactions that are there in this particular batch. So B as an immediate downstream activity for A will have to wait till A completes his part of the work for the 20th transaction. Is it not? When it is being executed in a batch, so A will perform his part of the activity for all the 20 transactions in that batch. So what will happen? B as an immediate downstream activity for A will have to wait till A completes his part of the work for the 20th transaction. Now, if it is like a one piece flow, how it will be done? So A will pick the first transaction, will perform his part of the work, and immediately hand it over to B. So A will then pick the second transaction and will start performing his part of the work. Meanwhile, B would have completed his part of the work for the first activity and would actually send the transaction to C. So A meanwhile would have completed the second transaction and would be in a position to pass it over to B. So this is what we would call as one piece flow. So in a one piece flow, as we can see, B as an immediate downstream activity will have to wait only till the time A completes his part of the work for the first transaction, not beyond that, right? So B as a downstream activity will have to wait only till A completes his part of the work for the first transaction, not beyond that. So this is what we can achieve through one piece flow. So lean as a process improvement methodology always advocates one piece flow over batch processing. So lean as a process improvement methodology always advocates one piece flow over batch processing, right? If batch processing is inevitable, then we can't help it. But it's always better to execute this as a one piece flow so that we can save lot of time, right? So in fact, if it is a one piece flow, the time taken to process all these 20 transactions will be far less than the time the process would take when they adopt batch processing, right? So it is like traveling by an elevator and escalator. So in elevator, what happens? So you need to wait for the elevator to arrive at your floor. Meanwhile, some more people would have joined. You will all enter inside the elevator as a batch and you'll go to your respective floors, right? But when it comes to escalator, the escalator keeps moving, right? So as and when you decide to go to the next higher floor, you can simply hop on to that escalator and travel, right? So there is no waiting time at all. But whereas when you wait for an elevator, there is obviously some amount of the waiting time. So you can draw parallel, right? So waiting time that you would experience when you travel in an elevator is like batch processing. Whereas, when you travel in an escalator, it's like a one-piece flow. People can just keep hopping on to the escalator and move to the next higher floors, right? And finally, we have the transportation waste. So transportation is more pertinent to a manufacturing scenario where the production site could be at a faraway place from the supplier site as well as from the market. So once the production site requires us or places a demand for the supply of raw materials. So the raw materials might have to be transported over a longer distance from the supplier site to the production site. Or once the production site finishes production, so the finished goods will have to be transported over a longer distance to the market. So whenever there is a transportation waste happening, so it is only going to, delay supply of the goods, right, in a manufacturing environment. And not only that, it will also incur huge cost, right? Transportation doesn't come free of cost. It will obviously incur a huge cost. But in an IT or ITES setup, right, we can always find out a similar example wherein there is a meeting which is taking place at a different location in the city. So, if it is a very big organization, they may have different officers at different locations, at multiple locations within a city. Right? It's quite common. So there is a meeting taking place at a different location within the city, and you are required to attend that meeting in person. So it could be an half an hour meeting, but then you need to travel some 20 to 25 kilometers one way to attend that meeting. So when you actually commute, so if you're doing a self-driving, you will not be able to concentrate on any other activity. Yes, please. So you'll not be able to concentrate on any other activity. So you'll be focusing only on driving the vehicle, and you will have to, spend some 1.5 hours in that city traffic to travel that 25 kilometers distance to reach the meeting location, attend the meeting, and then travel back to your home location, right? So covering, 25 kilometers the other way around. So this is typically a transportation waste. So if that meeting can be attended through a video call, so that would help us to save a lot of time, save a lot of money as well, right? So these are the 7 types of waste that we can easily identify in our processes. And the plus one waste or the 8th waste is called as KSA waste. So what is KSA? Knowledge, skill, and ability waste. So what is this? Say, for example, there is an employee with a superior skill set. So the employee is an MBA in finance, capable of performing some high-end financial analysis and provide some useful insights to the management team. But then that employee is made to work on a data entry job. It's not like, data entry job is an inferior work. But then what we are trying to tell here is the employee's potential has not been fully utilized by the management. The employee who is capable of performing some high-end financial analysis is made to work on a data entry job. So obviously the employee skill set has not been properly utilized here. And what will happen? So obviously the employee is not going to enjoy performing the data entry work. So over a period of time, the employee will get frustrated, demotivated, and will even think about quitting the organization. So attrition is a long-term repercussion of this KSI waste. Just quite evident in all the organizations, right? You yourself would have seen. So that is where the skill matching becomes all the more important, right? So we need to understand the employee skill set and accordingly provide the job for that employee. Or it should be the other way around. So whether that particular job requires a specific skill set. So if you have an employee with all those skill sets, then it's always better to hire that employee rather than going for uh, an employee who doesn't possess that skill set, right? That will become much more problematic. So it can happen the other way around also. Here we talked about an employee possessing some excessive skill set not being properly utilized. So it can happen the other way around also. There is an employee who is just a graduate. He doesn't, possess, too many skills. But then that employee who is fit to perform the data entry work is made to perform some financial analysis work and provide some insights to the management. That employee would be struggling, right, to perform his activity every day. The management would be pulling up that employee, citing that the employee is not doing his job in a proper way. But little would they realize that the employee is not skilled to perform that activity, right? It's very important for us to understand what is the capability of an employee. So here again, the employee is not going to really enjoy performing this high-end work. So the employee would definitely feel frustrated and demotivated, might also think about quitting the organization in due course of time. So this knowledge, skill, and ability waste, the long-term repercussion would be attrition, right? So this is something that we can easily identify in our own organization, in our own team itself. Fine. Now, how to identify all these ways in the process chain and how to eliminate them or how to minimize them. So we have set of lean tools. So we are just going to look at some of the prominent lean tools that would help us to identify not only the ways in the process chain, but also how to eliminate the same from the process. So the first lean tool that we are going to quickly look at is VSM. So the full form is value stream mapping. VSM, the full form is value stream mapping. It is typically a process flow. VSM is nothing but a process flow. So which would contain not only the material flow, but also the information flow, right? So that is the difference, main difference between VSM and a typical process flow. So in a typical process flow, we would have mapped only the material flow. It could be a hard material, it could be a soft material, right? But then in a VSM, we will not only map the material flow, we will also map the information flow. If there is any kind of information flow happening between the two entities in a process, that also will get mapped in a VSM diagram. So this is how the typical VSM diagram will actually look like. So we will have supplier on one side and the customer on the other side. So each entity, right, will be provided with a symbol. So if it is supplier or a customer, this is a kind of symbol that we will use, right? Or if there is any information flow happening, so it would be marked by a lightning sign. So when you find a lightning sign, so this arrow mark would actually signal the material flow. So how it passes through the various stages in the process. But if you find any lightning sign in between two entities, that would indicate that there is some kind of an information flow happening between these two entities. So we can always find out what is that information flow, whether it is some follow-up being done by the second activity with the first activity. So why that follow-up is being done? How can we avoid that follow-up? Because follow-up, we all know, is a wasteful activity. So this information flow also will be mapped in a VSM diagram. And not only this, we will also have some of the critical matrices being tracked for each of the milestone activity in a process. So we will have all those critical matrices being tracked for each of the milestone activity in a process. So what are these matrices? So number one, the volume inflow. Number two, number of defects. Number three, number of backlogs. Number four, processing time, right, for that activity. And number five, the waiting time in between the two activities, right? So all those things will be mapped in a VSM diagram, even though they have not given the full set of metrics in this diagram. So you can see they have tracked the time taken for each and every activity and also the waiting time in between the two activities here. So the waiting time is also displayed here, right? So apart from these matrices, as I told you, we'll also have the number of volume, inflow, and also the number of backlogs. So if we find the backlogs to be piling, right, for a particular activity, we can clearly understand that there is some issue with that particular activity and people can immediately go and attend to it. So if it is like an agile scenario, as one of the participants rightly pointed out, right, we can look at the process being executed in a live environment. So there will be a coordinator who would be looking at, how all the people who are associated with that process are working, right? Their respective activities are executing their respective activities. And in case of any backlogs getting piled up for a particular activity, we can clearly understand that there is some issue. So you can immediately go and attend. Or if you are noticing higher number of defects, right, in a particular activity, then also we can understand that there is some issue with that activity. So there could be a bottleneck, right, in that activity. Or if you are able to observe a higher processing time than usual, then also we can understand that there is some problem with that particular activity. So these are, some of the indications which would actually help us to understand that there is some bottleneck, right, connected with that activity. So we can always, probe further, find out what is the waste and look at eliminating the same. So from that perspective, we can say that VSM is a diagnostic tool which would help us to identify the waste hidden in a process chain. So VSM is a typical diagnostic tool which would help us to identify the waste hidden in a process chain. And the next tool that we have is 5S plus 1S. Very, very famous, right? 5S plus 1S. In fact, you would have heard about this tool and you would have also worked on this tool, right? So this 5S plus 1S is a tool which would help us to maintain an orderly workplace in order to boost productive work environment. So there can be a couple of questions relating to this 5S plus 1S. So 5S plus 1S is nothing but a tool used for maintaining an orderly workplace in order to boost productive work environment. And in fact, when you work on a lean project, this is the first activity that we will perform. This 5S plus 1S is the first activity that we will perform as part of the lean project. So there can be a question on this, as I told you. So they would have asked you the final assessment, which activity will be performed first as part of your lean initiative or a lean project. We need to pick the option 5S plus 1S. That is the correct answer. It's very, very simple to execute. So we can even practice this 5S at home. So I will when we quote these examples, you will definitely understand, how this 5S can be implemented at home as well. So that is the beauty of majority of these quality tools, right? So all these quality tools need not be executed in an office environment. These tools can also be executed in our home environment, right? So we can also kind of replicate all these things in order to take some personal decisions as well. So what are these 5S's? So we have Japanese names for all these 5S's, but then I have provided only the English names here. So sort, set in order, shine, standardize, and sustain. So these are the 5S's. So again, that plus 1S got added recently, and that is safety, right? So if you look at these 5S's, the first 3S's are activities: sort, set in order, shine, or activities. Standardize and sustain are behaviors, right? The first three S's are activities, and the final two S's are behaviors. Now, let us take a simple example and see how to perform this 5S activity. So we will take the example of maintaining documents in our computer system, right? Maintaining documents in our computer system. So when you perform the sorting exercise, what we will do, we will list down all the documents that are available in our computer system and try to figure out which of these documents are required in the future and which of these documents are not required at all in the future. So those documents which are not required at all in the future can be eliminated straight away. So suppose you decide that this document is not required in the future, then you can look at eliminating it straight away so that we will make the document maintenance process much more simplified in our computer system. So that is the basic idea. So that you'll be able to retrieve a particular document without any delay, right? So sorting is the first step, wherein we will identify all those documents that are not required in the future and we will straight away eliminate it, right? And those documents which are required sporadically in the future, say once in 3 months or once in 6 months, so those documents will be placed in a drive, right, within the system. So those documents will be placed in a drive within a system. And those documents which are required by you on a routine basis or on a day-to-day basis will be placed on the desktop. So this is how you'll arrange all the documents in your computer system, right? So when you sort, you will eliminate all those documents that are not required in the future. You will look at placing all those documents in a drive which may be required sporadically in the future, say once in 3 months or once in 6 months, and you will maintain all the documents that you would require on a routine basis right on the desktop so that you'll be able to retrieve those documents without having to navigate through different paths. So that is the sorting exercise that we will do. The next one is set in order. So what is set in order? Set in order is based on the principle that there is a place for you to keep each and every item, and the item also should be kept at a proper designated place. Now, having decided that these are the documents that will be required by me, so what is that I need to do? I need to come up with a folder system, right? So suppose you are maintaining documents pertaining to some 10 customers. So what you will do? So in order to set an order, you will first create a master folder, the customer name. Within the master folder, you'll have various subfolders, right? So one subfolder may contain the documents pertaining to contracts and agreements. Another subfolder may contain documents pertaining to review meetings with that customer. And the third subfolder may contain documents pertaining to the metric dashboards. So like this, a different set of documents will be maintained in different subfolders under the main folder, which will be in the customer name. So when you name the subfolder, so you will provide the customer name, the beginning, underscore, you will put contracts or agreements. So meaning contract and agreement documents are very much available in the subfolder so that you'll be able to easily recognize it. So that is the main objective with regard to the set in order practice. So you should be able to clearly recognize, in which folder a particular document has been kept, right? That is the set in order. So it's all about, structuring all the documents in some proper folder system. So that is what is set in order when it comes to maintenance of documents. But then if you look at a surgical operation theater, right? So how the surgical equipments will be structured or placed. So it will be placed in, different compartments or different boxes. You would have seen that, right? So why it is actually kept in different boxes? Because it will be easy for the assistant to retrieve a particular surgical equipment as and when the surgeon requires it, right? So you will have a box containing, different types of scissors. You will have a box containing different types of needles. You will have a box containing different types of knives. So as and when the doctor or the surgeon requires a particular surgical equipment, so the assistant need not actually spend a lot of time in retrieving that surgical equipment, will be able to hand it over without any delay. So that is the main thing here as far as set in order is concerned, because you cannot afford to kind of delay providing a surgical equipment to the surgeon in an operation theater, because each and every second is going to be fatal to the patient's life. So set in order has to be definitely followed there. Otherwise, it will only result in inordinate delay picking up a particular, surgical equipment, which should not happen in an operation theater. Similarly, right, in our homes, you would have found, right, the set in order is very, very essential. So, say for example, there is a person who has come back from office. So, what that person will do, he will actually remove his ID card, office ID card, and throw it in one corner. He will just keep the laptop bag in some other corner. He will just keep the wallet in some other place, and then he'll comb the hair and then keep the comb at some other place. So like this, all these things will be done, the previous day evening. Next day morning, when the same person starts for the office, he will end up searching for all these items. So this might have even occurred to us, right? So why? Because all these items have not been kept at a proper designated place. So there is a place for you to keep the ID card. There is a place for you to keep the laptop bag, and there is a place for you to uh, keep your comb. There is a place for you to keep your wallet. If only all these items had been kept at a proper designated place the previous day evening, you will not end up searching for all these items the next day morning, right? So set in order practice will help us to retrieve all the wanted items without any delay, provided they are kept at a proper designated place, right? Similarly, if you look at our kitchen, right? So if only the set in order practice is followed, then even an outsider can enter your kitchen and then pick a particular food ingredient without any issue, because you have the labeling done for all the racks. So there will be a particular rack containing all the spices. There will be a particular rack containing all the grains. There will be another rack containing all types of oils. So within that rack, you will have different containers containing different types of grains, different types of spices, etc. So all those containers will be properly labeled. So once you have the system, it will be very easy even for an outsider to enter your kitchen and then kind of pick a particular food ingredient without any delay. So this is nothing but the set in order practiced at home, right? So all these things you can always draw parallel with the happenings at home. So people would have actually properly labeled all these food ingredients in different containers so that it becomes very easy for them to retrieve a particular food ingredient whenever it is required. And the third is the shine. What is shine? Shine is all about cleaning up on a routine basis. So in case of file maintenance, so if you keep cleaning up without allowing things to accumulate, then you are performing this activity called shine, right? So once you decide that this particular document is not going to be required by me, so you should not wait for a good day to actually eliminate that document from your system. You should remove it straight away as and when you decide that this is not required by me in the future. So that is what is shine. It's all about cleaning up the system on a routine basis. So once you keep performing all these three activities, right, on a day-to-day basis, then we'll be able to standardize this practice, right? We'll be able to standardize this practice. That means we can make this as a habit, right? So once you make this as a habit, then we will be able to sustain this forever, because habits are very difficult to change, right? So once you have made all these good practices as your habit, then you'll be able to sustain this forever. So standardize and sustain are behaviors, whereas sort, set in order, and shine are the activities. So the safety part is nothing but the restrictions that you put in place in your computer system in order to prevent any viruses from attacking your documents, right? The safety part, as far as file maintenance is concerned or document maintenance is concerned, is nothing but all those antivirus softwares that you would install in your system in order to prevent the software viruses from attacking all these documents, right? That is the safety part of it, which got added to this 5S. It's a very simple exercise, but highly effective. And the next one that we are going to look at is Poke-OK. So what is Poke-OK? So poke is a Japanese term meaning mistake proofing. So this poke is nothing but the control measures that we would implement post identifying a risk in the operations. So poke are nothing but the control measures that we would implement post identifying a risk in the operations. So there are 3 levels in poke. So what are the 3 levels? Warning, prevention, and shutdown. So look at all these 3 levels through a very simple example. So we all would have filled in this online application forms, right? Sometime or the other, we would have definitely filled in an online application form. So when you fill in an online application form, suppose you have filled in a particular field with some incorrect content, and if the system is going to throw a warning message, right? The system is going to pop up a warning message saying that this field has not been filled in with a proper content. Then it becomes a warning okay. Yes, so when you fill in an online application form, and if the system is going to throw a warning message saying that this particular field has not been filled in with a proper content, then it becomes a warning okay. But this warning can be ignored by us and we can proceed further. The system is not going to prevent you from proceeding further. In case of warning okay, the system will throw a warning message to you. But as a user, you can still ignore that warning message and proceed further. The system is not going to prevent you from proceeding any further. That is the warning okay. So this warning okay will be implemented when the repercussions due to the deviation is not all that severe. So the repercussion due to the deviation, what is the deviation? That incorrect content that you would have actually filled in a particular field, right? The repercussions due to that is not all that severe. We can look at implementing a warning okay. So nothing serious is going to happen. But then this is not the right way to fill in this particular field. So this is how we need to fill in. So if that is the kind of message you want to pass on, then we can implement this warning okay, because that will not prevent the user from proceeding further. So that will only provide a warning message. So as I told you, the user can choose to ignore that warning message and proceed further. System is not going to stop that person because that deviation is not going to result in serious repercussions. Only then we will implement warning okay. The second one is prevention. The same online filling exercise. Suppose you have filled in a particular field with some incorrect content. And if the system is not going to allow you to proceed further unless and until you correct that particular field with some correct content, then it becomes a prevention okay. So in case of prevention okay, any kind of deviation from the standard practice, if the system is able to identify it, then it will not allow you to proceed any further. It becomes a prevention okay. So password is a prevention okay. So what will happen if you type the password incorrectly when you log into your system? You will not be allowed to log into your system, right? Similarly, if you want to access your banking website and if you are banking password incorrectly, the system will not even allow you to log into your banking website. So these are all prevention okay, where the system will prevent you from proceeding further in case of any deviation from the standard practice. So here, the repercussion due to that deviation could be slightly severe. So that is why you would implement a prevention okay mechanism. And the third one is shutdown okay. So shutdown okay is a scenario wherein the entire system will shut down moment it identifies some deviation from the standard. The same online application filling exercise, you have filled in a particular field with some incorrect content. If the system is going to recognize it, and if it is going to shut down completely, coming out of that application itself, right, then it becomes a shutdown okay. The shutdown okay will be implemented when there is a serious repercussion that can happen due to that deviation, right? So if there is going to be a serious repercussion due to that deviation, which might actually result in some damage, then we will implement this shutdown. Okay. Similarly, the password, scenario. So when you want to access your banking website, and if you type your password incorrectly 3 consecutive times, what will happen? The banking website will get shut down, right? You'll not be able to, attempt it any further, right? You cannot play around with your password, so it will not allow you to, attempt any further. So what you might have to do, you might have to probably identify yourself, your banking executive, and then look at resetting the password, and it will allow you to access the banking website only after, say, 24 hours, right? So this is kind of a shutdown. Okay, right? Similarly, you would have heard about this item called trip switch. So trip switch will be installed in all our homes, right? So what is the basic functionality of this trip switch? So trip switch will monitor the power supply within our house. So the power supply has to be right within a particular range. So if it is going to exceed that range, or if it's going to be below that range, then the power supply can potentially damage the electrical and electronic items connected to the plug. So this is what we would call as high voltage and low voltage, right? Both high voltage and low voltage can potentially damage all these electrical and electronic items connected to your plug. So this trip switch will monitor whether the power supply is within that acceptable range or not. So if it is not within that acceptable range, it will recognize immediately and it will cut off the power supply. So once the power supply is cut off, it will help us to prevent any damage from happening to these electronic and electrical items connected to the plug, right? So that is the basic functionality of this trip switch, and this is typically the shutdown okay that we would have actually exercised through this. So moment it is deviating from the standard, the power supply is deviating from the standard, the trip switch will recognize and then it will immediately cut off the power supply to the house. So then you can go and look at the mains board and you will find the trip switch being off because it would have cut the power supply because of the voltage fluctuations. So this is typically a shutdown. Okay. So these are the 3 levels of okay or mistake proofing. Typically the preventive measures that we would implement in place in order to prevent a damage that can be caused due to a risk identified in the operations. So the damage has not yet happened, but then it can actually prevent the damage from happening in the first place when we implement all these okay measures, right? So this will be done after we identify a potential risk in the process. And then we have Jidoka, again a Japanese term meaning automation with human intelligence. So Jidoka is not a simple automation. So this is an automation with human intelligence. So this is also called as automation. So Jidoka is also called as automation. So what is the simple automation? So you might have seen all these robotics automation, right? So what these robotics automation will do, suppose you want to transfer some information from certain files to another software application. So you can implement a robotics automation to perform that routine work. Say, for example, you have thousands of patients' records to be transferred from an Excel format to a software application. So you can implement a robotics automation to perform this activity. So the robotics automation will get inside that Excel file and will pick all the information relating to a patient and it will transfer it to a software application. So this is kind of a routine work which will be performed by the robotics automation day in and day out. So this is not called as Jidoka. So Jidoka is a sophisticated automation. So this is an automation with human intelligence. So there is some human logic which is embedded in this automation called Jidoka, right? So what is the example? So the example, say we have some 3 different processing queues, right, meant for processing the application or online application submitted by the applicants belonging to 3 different age groups. So there is a separate processing queue to process the applications submitted by the applicants who are less than 30 years of age. There is another processing queue which is supposed to process the applications submitted by the applicants who are between 30 and 60 years of age. And there is a third processing queue which is supposed to process the applications submitted by the applicants who are above 60 years of age. Now, when the online application is filled in, this Jidoka automation will scan through the application and will find out what is the age of the applicant and accordingly route that application through the appropriate processing queue. Then only it becomes a Jidoka automation. Say if there is an application submitted by an applicant less than 30 years of age, and if this Jidoka automation is going to recognize that this is an application submitted by an applicant less than 30 years of age, and it has to be routed through the appropriate processing queue. And if it is going to recognize the processing queue through which this application needs to be routed through, then in that case, it becomes a Jidoka automation, right? So the automation itself will identify through which processing queue a particular application needs to be routed through. Suppose this automation is confused, right, in identifying which processing queue it has to route through a particular application. This will not actually, perform an incorrect activity. So it will stop then and there. If it is confused as to, it cannot decide through which processing queue a particular application needs to be routed through, this Jidoka automation will not function in an incorrect manner. So it will stop then and there, so that the supervisor who is manning these automations can come and look at what is the issue, can set right the issue, and then resume the automation again, right? So this is the beauty of Jidoka automation. So you can be rest assured that the incorrect processing will not be done in case of Jidoka automation. Only if it is 100% certain that this application needs to be routed through a particular processing queue, it will not even kind of process it. It will stop then and there. Then we have Kanban. So Kanban is a dashboard kind of a system which will help us to understand the status of each and every activity that we would perform in a process chain, right? Say, for example, so in even this agile system, we were discussing about it, right? So we will have a Kanban kind of a dashboard which will clearly indicate what was the volume inflow that for that particular activity. So how many, transactions have been completed already? How many transactions are in progress? And how many transactions are yet to be completed, right, before the end of the day today. So all these information will be provided on a live environment. So in that case, it becomes a Kanban kind of a system, right? So even this call center you would have seen. So there'll be a huge dashboard which will provide information with regard to how many calls actually flowed in and how many calls were actually attended and how many calls got abandoned, right? Because enough executives, call center executives were not there. So people were not able to pick those calls and it got abandoned, right? So all these information will pop up on the dashboard. So the supervisor will be able to clearly understand whether the call traffic is normal or it is excessive. So if it is excessive, we can see a higher abandonment rate taking place. In that case, the supervisor can immediately look at, provide some additional staffing, right, for that activity. So through this, we can look at minimizing the abandonment rate, right? So we will not allow any call to be missed. So we will have some additional staffing provided. So all these things will take place in a live environment. So that is the beauty of this Kanban system, right? And then Kanban with just-in-time concept can help us to eliminate the inventory type of waste. So how it can be done? So just look at a restaurant scenario. So as I told you, all these, food ingredients or the finished food products are very, very difficult to preserve, number one. and it will also have a very limited shelf life. And beyond that shelf life, we cannot use that food item. It will be hazardous to the health of the user. So it will, kind of result in various health complications for the user. So people would be advised not to use any of these food items beyond its shelf life. So we need to throw it out as a waste. So that being the case, we definitely need to adopt this Kanban system in a restaurant kind of a scenario. So we will have the Kanban dashboard being maintained for all these, raw materials, the food raw materials, so that we will keep it in our store. So we will have the current stock of the raw materials displayed for all these food items, right? That will be listed in the Kanban dashboard. And as and when the stock for a particular food raw material reaches what is called as economic reorder quantity level, so the Kanban dashboard will throw a warning sign. So it will probably, kind of indicated through a red color light. So red color light will glow, and we can, understand that this particular raw material has to be purchased immediately. So we need to place the order for purchase of this raw material. So the purchase officer will look at the Kanban dashboard and then will understand that this raw material needs to be purchased immediately so that the production doesn't get hampered, right? So the economic reorder quantity level would be fixed based on how much time it will take for you to get that raw material from the market and what is the production rate, right? So how fast, the food items which are prepared with this raw material are moving, all right? So based on that, you would have fixed the economic reorder quantity levels. The production rate is going to be high, or if it is going to take a longer time to get that raw material from the market, then you will fix a higher economic reorder quantity level for that specific raw material. So once the raw material stock reaches that economic reorder quantity level, so the purchase officer will know through this Kanban sign. So it will actually, kind of indicate that this raw material has to be purchased through this red color sign, as I told you. So the purchase officer will be able to place the order for replenishing that raw material, right? So this is typically the Kanban dashboard that we can actually utilize in a restaurant scenario. So this would actually help us to keep enough stock of the raw material. So we will not keep excessive stock of raw material, number one. And number two, we will also not run out of stock, because as and when the raw material stock reaches that economic reorder quantity level, so we will immediately, order for purchasing that raw material once again, right? So you'll not run out of stock. At the same time, we don't have to keep excessive stock of raw materials due to this Kanban dashboard. So this would typically help us to eliminate or reduce the inventory type of waste. Then we have standardization. So what is the standardization? Standardization is all about executing the process in a standard manner as per the details provided in the process document. So process document is a standard operating procedure document, so which would have detailed how the process needs to be executed. So all these new joinees will be trained based on this process document, right? So they will be trained how to execute the process as per the details provided in the process document. So this standardization would help each and every employee to execute the process in a standard manner. So when all the employees working that process execute the process in a standard manner, then we can be rest assured that the output delivered by that process will also be consistent and standard, right? So you don't have to worry about the inconsistencies or variability in the output delivered by that particular process. So the typical coffee preparation example can be quoted here. So when all the uh, people who are engaged in coffee preparation, as far as that particular restaurant is concerned, irrespective of whether they are placed in a particular outlet, so they will be able to prepare the coffee in the same way, because the same kind of procedure will be followed. So when they execute the process in a standard manner, they can be rest assured that the output delivered by the process will not contain lot of variations or inconsistencies. So this practice would help us to eliminate what form of waste? This would actually help us to minimize or eliminate the Mura form of waste. Mura is about inconsistency or variability that you would observe while executing the process. And then finally, we have Haijunka. Haijunka, again, a Japanese term meaning load leveling. So what is this Haijunka technique? It's all about understanding the workload, the total workload, and distributing the workload equally amongst the team members. Or if you have machineries, equally distributing the workload amongst the various machineries, right? So when the equal distribution of workload takes place, right, within the team, then obviously it would help us to eliminate what form of waste? Muri form of waste. So we would be able to eliminate Muri form of waste when we practice Haijunka or load leveling. So these are some of the important or critical lean tools that would help us to not only identify the waste in a process chain, but it will also help us to eliminate those waste from our process. And finally, we are going to look at some 3 lean metrics, right? So the first lean metric is cycle time. So what is cycle time? So cycle time is nothing but the processing time of each and every activity in a process chain plus the waiting time between any 2 activities, right? Say for example, we have these 3 activities A, B, and C. Activity plus the waiting time in between the 2 activities will be taken into account for calculation of the cycle time, right? So cycle time would actually kick in only from the moment A starts the activity, starts his part of the activity, right? So A is the first processor in this process chain. So moment A starts performing his activity, the cycle time would actually start kicking in, right? And then we have what is called lead time. So what is this lead time? So lead time, as we can see, it is cycle time plus the preparatory time at the beginning of the process plus the time taken at the end of the process before the output is delivered to the customer. So what is this lead time? So lead time is nothing but the cycle time. So cycle time, as we can understand here, is part of the lead time, is a subset of the lead time. So lead time obviously will be much higher than the cycle time. So it is cycle time plus the preparatory time at the beginning of a process. So there is some allocation activity that is carried out before A commences his part of the work. So the time taken for this allocation activity also will be taken into account when we calculate the lead time. And also the time taken at the end of the process. After C has completed the final activity, the output is lying idle without being delivered to the customer. So the time the output is lying idle will also be taken into account for lead time calculation. So lead time is the end-to-end time taken for the process to get the input and deliver the output to the customer, right? So cycle time, as we can see, will be a subset or will be part of the lead time calculation. So we can very well understand that your customer would be very much interested in this lead time calculation rather than the cycle time calculation. So for the customer, the end-to-end time is very, very important, right? So say, for example, there is a customer support process. So this customer support process is supposed to provide resolutions to the customer query, right? So the customer, after buying the product from that organization, will have lot of doubts or clarifications regarding that product. So they will raise it in the form of a query. So it can be a oral query, it can be an email query, whatever it is. So when the query is raised by the customer support team will be there, or we call that as customer care team. So the customer support team is supposed to provide proper resolution for a customer query. Now, the customer is raising an email query, right? So moment the customer sends an email, right, from his inbox, So the lead time would start kicking in, right? So that query sent by the customer can actually lie idle in the customer support team mailbox. So that is not customer's botheration. As far as customer is concerned, the customer has sent his query. So the query might be lying in the inbox of the customer support team for a day. And after that, only the customer support executive will start working on that query. So the cycle time would actually kick in only from the moment the customer support executive starts working on the query, whereas the lead time would have already kicked in from the moment the customer pushes the query into the customer support team mailbox, right? See the difference here. So between the cycle time, the lead time, so that is why you would find your customers always complaining that the delivery is not taking place as per the agreed timeline. Whereas you would be claiming that you have been doing a fantastic job with regard to the timeline, right? That needs to be maintained for delivering the output to the customer. So you would be painting all these time related metrics in green color and presenting a very picturesque dashboard to your management team. Whereas on the other side, the customer would be complaining that, you're missing out on the timeline. Why this is happening? Because the customer would have calculated the time as per the lead time logic. You would have calculated the time as per the cycle time logic and presented a better picture to your management, right? So this kind of discrepancy can be there. So that is why it's always better to come up with the operational definition for all these time related metrics, because we'll not know whether the calculation is done as per the cycle time logic or as per the lead time logic. So it's always better to come up with operational definition. What do you mean by operational definition? It is nothing but the explanation of the calculation logic that we are going to adopt for calculating a particular metric. So that is what we would call as operational definition. So whether we are going to calculate the time metric as per the cycle time logic or as per the lead time logic. Otherwise, what will happen? The service provider will calculate the time as per the cycle time logic, whereas the customer would be calculating the time as per the lead time logic. So the service provider would be presenting a better picture to their management, whereas the customer would be complaining that the timelines are not being maintained with regard to the delivery of the output. So this kind of a miscommunication or kind of a disagreement with regard to the calculation logic can be completely avoided if you are going to come up with the operational definition for a particular time related metric. So this is about cycle time and lead time. The third metric that we have is takt time. So what is this takt time? So this is the ideal time that should be taken for processing a unit item in order to meet the customer demand. Say for example, if the customer demand is for 100 units to be delivered in a day's time, and in a day we have some 8 productive hours. So 8 productive hours means in terms of minutes, it will be 480 minutes, 8 into 60, right? 480 minutes. It means 480 minutes. In 480 minutes, we need to produce 100 units. In 480 minutes, we need to produce 100 units. So per unit, how much time it should ideally take? 4.8 minutes. So we should not take more than 4.8 minutes to produce a unit item. Then only you'll be able to meet the customer demand of 100 units to be delivered in a day's time. But then you have done a time study and you have observed that it would take, say, 9.6 minutes to produce a unit item. Then what can you do? Right? So we need to come up with some additional staffing. So instead of having one person, executing this process, we will have couple of people executing this process, right? So we will do a time study. We'll find that it takes a longer time than 4.8 minutes. Then in that case, we need to come up with additional staffing, right? So that alone would enable you to meet the customer demand of 100 units to be delivered in a day's time. Clear? right? So this tag time logic can be used for estimating the number of employees I would require for executing a particular process based on the customer demand. So whatever is the volume in flow and whatever is the time that is given by the customer to process all these volumes. So we would need to accordingly have adequate staffing in my process to ensure that the delivery is done within the agreed timeline. So for that, this tag time logic can be used. So these are the three lean metrics that we have, right? So we will kind of go for a break now. So 15-minute break. So when we come back, we will get introduced to the core part of our training curriculum, which is Introduction to Six Sigma, right? So that will be after a 15-minute break. Hello, friends. I'm back. Hope you're all back as well. So let me share my screen. Yeah. So we'll now get introduced to Six Sigma. So Six Sigma, as we discussed yesterday, is a process improvement methodology introduced by Bill Smith and Michael Harry of Motorola. So Bill Smith and Michael Harry were some top executives, right, working in Motorola. So they were the ones who actually introduced this concept called Six Sigma. But then Sigma level, right, is a metric which would actually indicate the process efficiency or process quality. So sigma level, as we know, is a metric which would actually indicate the process efficiency or the process quality. So if the process has a higher sigma level, that means that process is high on efficiency or high on quality, as simple as that. But then, if it is such a powerful process improvement methodology, how come Motorola, introduced this Six Sigma methodology and made it more prominent to the entire world? So there is an interesting story behind this. So in the year 1986, Motorola happened to participate in a competition conducted by the US government for an award called Malcolm Baldrige Award. So in the year 1986, Motorola happened to participate in a competition for an award called Malcolm Baldrige Award, and this competition was organized by the US government. So the US government had put forth a condition for all the participating organizations that whichever organization wins this Malcolm Baldrige Award will have to disclose the methodology that they adopted to show higher process efficiency, right? So Motorola happened to win this award in the year 1986, and they had to disclose this methodology called Six Sigma methodology to the entire world. So this is how Six Sigma methodology became prominent to the entire world, right? Guys, if you're not talking, can you just put yourself on mute?
I'm sorry, I
Thank you.
missed to.
Fine. So even though Motorola introduced this technique called Six Sigma, it was General Electric, right, which adopted the Six Sigma methodology with lots of passion and interest during the 1990s. And they also reaped very high financial benefits. So from the year 2000 onwards, as I told you yesterday, most of the organizations across the globe have started practicing Six Sigma. But then what does this Six Sigma level actually would indicate? So Six Sigma level is supposed to be the world-class level, right? At this Six Sigma level or the world-class level, a process would contribute just 3.4 defects per million opportunities. So this is what is written as DPMO. So DPMO is a metric. So when I say 3.4 defects per million opportunities, it means, so if you want to understand this in a very crude way, suppose, there is an inspection team which is inspecting something like 1 million inspection parameters or 10 lakhs inspection parameters. 10 lakhs is equal to 1 million, 1 followed by 6 ciphers, right? So if the inspection team is going to inspect on 1 million audit parameters, and if they're able to identify only 3.4 defects in these 1 million parameters, then the process is said to be functioning at Six Sigma level, which is supposed to be the world-class level. So at Six Sigma level, we are not having a zero defect kind of a scenario. We still have 3.4 defects, but this is per 1 million opportunities, 1 million fields that are inspected. And if the inspection team is able to identify just 3.4 defects in these 1 million fields, then the process is said to be functioning at Six Sigma level, which is the world-class level. So in terms of process efficiency or quality, it works out to 99.99966% process efficiency. So this 3.4 defects per million opportunities would translate into 99.99966% process efficiency, right? So 3.4 is the defect rate, whereas 99.99966% process efficiency is the accuracy rate, right? So both in terms of defect rate and accuracy rate, we have actually indicated the value that the process would be exhibiting at a Six Sigma level, which is the world-class level, right? So there are certain processes which are supposed to function at more than Six Sigma level. Say all those processes that might have a direct impact on the human life, they are supposed to perform at more than Six Sigma level, right? So we would not want to have even this 3.4 failures per 1 million cases, right? So we want each and every case to succeed. So we would not want even this 3.4 failures in 1 million cases. So we would want each and every case to succeed. So there are certain processes which might have a direct impact on the human life to perform more than the Six Sigma level, right? Say, for example, the aircraft takeoff and landing process. So it has a direct impact on the passenger lives, right? So we would not want even this 3.4 failures per 1 million takeoff or 1 million landings to happen. So these processes are supposed to function at more than Six Sigma level, right? But at Six Sigma level itself, we would call that as a world-class level because 3.4 defects per 1 million opportunity is a very negligible quantum, right? So that being the case, the process is very, very precise and it is functioning at a higher levels of efficiency. So that is the meaning of it. So there are three facets of Six Sigma. So what are the three facets of Six Sigma? So we all know that it is a process improvement methodology. And we also know that it is a benchmark metric because each and every process would strive to achieve that Six Sigma level, which is the world class level, right? So each and every process would strive to achieve that Six Sigma level, which is obviously the world class level. So it is a benchmark metric. But Six Sigma is also called as a philosophy. Why Six Sigma is called as a philosophy? Because yesterday only we discussed about this. So Six Sigma advocates identifying and attacking the root causes in order to improve the effect. So this sounds philosophical, like do your duty, the result will happen on its own. So you don't have any control over the result. That means you don't have any control over the effect. So what we need to do, we need to follow the right process. The result will happen automatically, right? So be attentive in this training sessions, revise all these notes, attempt the quiz questions that I'm going to send it across on a routine basis. Then you would automatically get certified as a black belt professional. So the result will happen automatically if you are going to follow the right process. So the Six Sigma practice of identifying and attacking the root causes in order to improve the effect sounds philosophical, like do your duty, the result will happen on its own. So that is why Six Sigma is also called as philosophy. And as I told you yesterday, we have a separate phase dedicated for identification of causes and root causes, and that is your analyze phase. Now, as part of our Six Sigma practice, we also need to be aware of the concept of variation, right? What exactly is variation, right? Because in a Six Sigma project, so we will not only try to improve our process performance with that of the target specified either by our customer or by our leadership, right? So leadership also needs to be treated as our customer. We will look at the definition of customer as part of the define phase. But then whatever target is provided to us, so first and foremost, we need to improve our process performance so that we are able to meet the target quite comfortably. That is the first objective. The second objective, having achieved the target or having achieved our project goal, it is very, very important for us to perform consistently around that level. So we have improved the process performance. So the next thing is to ensure that we are consistently performing around that improved level. That is also very, very important as far as Six Sigma is concerned, right? So we should not slip back to the baseline scenario after witnessing the improvement for some couple of months, which is what would normally happen, right? Most of the scenarios you will see the improvement taking place. The improvement will be there for say 2 or 3 months. The fourth month, if you see, the situation would have actually, come down to the baseline scenario, right? So that should never happen. So we should maintain that consistency in the improved performance. So when you are trying to improve the consistency in our process performance, that means we are reducing the variation in our process performance. Variation, the other word is inconsistency, right? So opposite of variation is consistency. So variation, as we can say, is an evil, right? It's not something that is desirable. So we need to look at minimizing this variation to a greater extent. Then only you'll be able to maintain that consistency in our improved performance. And for that, we would be learning all these statistical tools and techniques because statistics is considered as science of variation. Now you can understand why are we actually looking at all these statistical tools and techniques as part of our Six Sigma curriculum. Because this variation part is also equally important when we work on a Six Sigma project. So it's not enough if you are able to improve your process performance and achieve the target specified by the customer. We should also ensure that we consistently perform around that target level. So in other words, we need to ensure that the variation in the process performance is minimized to a greater extent. So that is also one of the key objective of the Six Sigma project initiative. So what is variation? Variation simply defined is nothing but any deviation from the standard. But then if you have a numerical data set, right? A collection of data points is what we would call as the data set. Say, for example, you have measured the weight of the unit product. So you have some multiple units produced. So the weight that you measure is something like this. So when you have collection of data points, we can say that this is a data set. So when we see differences in these measurement values in this data set, we will say that there is some variation in the process performance, right? So the quantum of variation can be measured using some appropriate metric, which we will see a part of the measure phase. So in the measure phase, we are going to learn about the descriptive statistics measures. So we will also learn about the matrices which would help us to quantify this variation, right? But then simply speaking, we can look at the measurement values in a data set. And if you find the differences in the measurement values, we can say that the process performance has some variation. So that is a crude way of explaining what exactly is variation. But generally speaking, variation is nothing but any deviation from the standard. So you have certain standard practices to be followed. But then if you are going to perform all these, best practices in a different way, that means we are deviating from the standard. And this deviation is what we would call as variation, right, in our performance. So when we have a numerical data set, as I told you, the differences in the numerical values is what we would consider as variation in the data set. So if all the data points are same, right? If it is like 2.58 kgs, 2.58 kgs, 2.58 kgs for all the units measured, then in that case, the variation will be zero. So it is 100% consistent, right? Understood the difference between consistency and variation. Both are, opposite terminologies. So variation, as I told you, is an evil. So we need to look at reducing the variation in order to improve the process performance consistency. And for that, we would be using the statistical tools and techniques because statistics is regarded as science of variation. Now that we have got introduced to the variation concept, we also need to look at the types of variation. So variation is of two types. The first one is the common cause or the chance cause variation. So what is this common cause variation or the chance cause variation? So these are the minor variations observed in a process performance for which we will not be able to assign a reason immediately. And this common cause variation we all need to remember is inevitable. So it will be there in each and every process. We cannot totally eliminate the common cause variation. If someone is going to say that I have totally eliminated the common cause variation and I have made it zero, that means the person is defying the logic. So this common cause variation is inevitable and it cannot be totally eliminated. So what we can do, so this common cause variation can only be reduced and that too through Six Sigma efforts. So this common cause variation can only be reduced and that too through the Six Sigma efforts. It cannot be totally eliminated. Common cause variation, as we can understand, is inevitable. That means it will be there. We can only minimize it. We can only reduce it and that too through Six Sigma efforts. So in a Six Sigma project, we are going to look at minimizing this common cause variation. And there is another type called assignable or special cause variation. So as we can see, so these are huge variations that we can observe in our process performance for which we will be able to assign a reason immediately. But then if this assignable cause is within our control, we can even look at eliminating it, right? So this is the characteristic of the common cause variation and assignable cause variation. So the other name for assignable cause is special cause variation. So the other name for assignable cause variation is special cause variation. So these are the huge variations that you would observe in a process performance for which we will be able to assign a reason immediately. And if this reason is well within our circle of influence, we can even look at eliminating it, right? So while common cause variation is inevitable and we cannot totally eliminate it or make it zero, we can only minimize it through Six Sigma efforts. Assignable cause variation is something for which we will be able to assign a reason immediately. And if that reason is well within our circle of influence, we can even look at eliminating this assignable cause variation, right? So let us look at a very simple example and try to understand what exactly is common cause and what is assignable cause variation. So this is very, very important. Say, for example, if we say that an employee on an average takes 30 minutes to reach the office from home, does this actually mean that the employee would be taking exactly 30.00 minutes each and every day to reach the office from home? Definitely no, right? When I say the employee takes on an average 30 minutes to reach the office from home, that doesn't mean that employee would be taking exactly 30.00 minutes each and every day to reach the office from home. So the employee would have taken round about 30 minutes on each and every day. So the day-wise time taken could be as follows. The first day would have taken 29.8 minutes to reach the office. Second day it could be 29.7. Third day it could be 30.2. Fourth day it could be 30.1. Fifth day it could be exactly 30.00. Sixth day it could be 29.9. Seventh day it could be 30.1. So if you see, for all these 7 days, the employee has taken round about 30 days to reach the office, right? But if you take the average of the time taken to reach the office, it may work out to 30 minutes, right? So that doesn't mean that the employee would have taken exactly 30.00 minutes each and every day to reach the office. It could be in and around 30 minutes. But then the employee would be wondering why there is a small difference in the time taken to reach the office, because he is driving the same vehicle, the same road condition exists, the same traffic condition exists. But despite all this, we notice a small difference in the time taken to reach the office. And this minor difference for which the employee is not able to provide a reason immediately is attributed due to common cause variation. So now we can clearly understand why common cause variation is inevitable in any process, in any system. We cannot totally eliminate. So when we say that we have eliminated the common cause variation, then we will get a scenario wherein the time taken to reach the office will be exactly 30.00 minutes each and every day, which cannot happen in a practical scenario, right? So that is not logical, right? So it will be, so even if you say that you have reduced the common cause variation, what we can do? So now if you see the data ranges from say 29.7 to 30.2, right? So we can possibly reduce this range from 29.7 to 30.2 to say 29.9 to 30.1. So that is the maximum that you can do. So you cannot, make it 30 for all the days. That is practically not possible. So that is what, is the characteristic of the common cause variation, which we need to understand very clearly. Otherwise, we will not be able to appreciate all the concepts that we are going to learn in the future, right? So we need to clearly understand that common cause variation is inevitable. It cannot be totally eliminated. It will still be there. What we can do is we can look at minimizing it or reducing it. As I told you, now the data range is 29.7 to 30.2. So this can be reduced to 29.9 to 30.1. That is the maximum that we can do. So we cannot look at making it 30 each and every day. That is practically not possible. If someone is going to show the data set containing the same measurement values each and every day, that means the person has cooked up the data, he has not collected the practical data, right? But then the same person on the 8th day has reached the office in 60.2 minutes. Now the supervisor would obviously question that employee why it has taken such a long time to reach the office. So for this huge variation in the time taken to reach the office, the employee would be in a position to provide a reason, right? So probably it was raining quite heavily. The employee had to take shelter and then come to office. Or the vehicle broke down. The employee had to get it repaired before coming to office, due to which he got delayed. So for this huge variation in the time taken, so the employee was reaching the office in and around 30 minutes. Suddenly the employee reaches the office in 60.2 minutes. So this huge variation in the time taken for which the employee is able to provide a reason is attributed due to assignable cause variation. Clear the difference between common cause and assignable cause variation, right? Another example. So this is a process related example. Say there is an employee who on an average commits around 2 errors per day. So does this mean that the employee would be committing exactly 2 errors each and every day? Not really, right? One day, the employee might have committed, say, 4 errors. Another day, it could be 0 error. Another day, it could be 1 error. Another day, it could be 3 errors. Another day, it could be exactly 2 errors. So like this, it could be in and around 2. So if you are going to take average of the error count, it will work out to 2 errors per day. And the employee also will not be able to attribute any reason why there is a small variation in the error count on a day-to-day basis. But the same employee is going to commit something like 25 errors on a given day. And if the supervisor is going to ask that employee why he has committed so many errors today, the employee would be in a position to provide a reason for that huge variation in the error count. So the reason could be because the employee, the keyboard in the computer system was not functioning properly. The employee, due to that, committed a lot of errors. Or the employee was not in a proper mental frame of mind, so due to which he committed a lot of errors in the process. So all these kind of reasons can be attributed for that huge variation in the error count. And this is what we would call as assignable cause variation. Clear? The common cause and assignable cause variation.
Excuse me.
Yeah.
In many scientific research, they say acceptable error or something in the data set. Is that the common cause or variation?
No. Common cause is nothing but the minor variation that you would find in the error count. It could be an acceptable error or whatever, right? So the minor variation in the error count. So even if you are committing higher number of errors, right? Say for example, you are committing say 25 errors each and every day, in and around 25 errors each and every day. So it could be one day 25 errors, another day it could be 27 errors, it could be 26 errors. But why there is a small variation in the error count, you will not be able to attribute any reason. But then suddenly you commit only 2 errors on a given day. So for this lesser error count, you will be able to provide a reason, right? Concrete reason will be there. Probably you would have followed some best practice and executed the process and you committed lesser number of errors. So if it is a positive thing, you can always look at adopting that assignable cause, right? So it has got nothing to do with the acceptable error limit, right? It's all about the differences in the error count, which would determine whether it is a common cause or assignable cause. So the differences in the error count is not going to be much, and you are not able to attribute any reason, right, with regard to the differences in the error count. Then we will call that as due to common cause variation. But then if the error count is going to be drastically different, it's going to be a huge variation in the error count. So it can happen on the positive side, it can happen on the negative side, right? So the variation can happen on the upper side of the data spectrum or on the lower side of the data spectrum, right? So like 2 errors per day. So in that case, we will be able to attribute a reason for that improved performance. And that is what we would call as assignable cause. So the acceptable limit is what we will call as the target, right? So the target is something totally different, right? So this has got nothing to do with common cause and assignable. So common cause, the differences in the error count, which we need to look at.
So
Right.
if we go back, sorry, to the philosophy itself and 3.4, what do we call them? The error of Six Sigma. The 3.4, it's like acceptable.
That is an improved process. See, in Six Sigma, we also talk about whether the process performance during the baseline stage is consistent or not. So we know that the process performance is not all that great, right? The process performance is bad. That is why we have picked up a Six Sigma project to improve the process performance. But then we would want the process performance to be consistently bad during the baseline scenario. So a process performing on a consistent basis doesn't mean that the process performance is good. The process can also perform consistently bad, right? And that is what we kind of look forward to during the baseline stage in a Six Sigma project exercise, because you'll be able to apply all these Six Sigma tools and techniques only if the process performance is consistent. That means the process should have been influenced by common cause variation alone. There should not be presence of any assignable cause variation influencing the process performance.
Yes.
Right? So consistency is totally different from good performance. A process can also perform consistently bad. We need to be aware of it. Anyway, we will look at these things in detail when we step into the measure phase. So you will understand how a process can actually perform consistently bad. That is what is required, right? Because you know that the process performance is bad, but at least it should be consistently bad. It should not be erratic. One day it is really good, another day it is very, very bad, third day it is somewhat average. This kind of a performance you wouldn't want from a process, right? So in that case, even if you are going to make an improvement, you will not know whether it is due to your efforts or due to the erratic nature of the process.
Yes.
Fine. So let us look at yet another example in order to understand that common cause variation is inevitable in any process, in any system. So we are going to get introduced to this transformation function. right? So this transformation equation or transformation function, which is also called as the regression model. It is in the format y is equal to f of x plus, there is a notation called epsilon. So this is a notation called epsilon, which would denote common cause variation, right? So what is y? Yesterday only we understood that y is nothing but your effect. So effect is denoted by capital Y in Six Sigma. X is denoted, that is cos is denoted by capital X. So X stands for cos. So y is the effect and x is the cause. So when I write y is equal to f of x, it means y is equal to function of x. So that means y as an effect can be influenced by a single cause or multiple causes. So that is the meaning of it. So y as an effect can be influenced by a single cause or multiple causes. So that is the meaning of y is equal to f of x. And as I told you, epsilon is a notation which would denote common cause variation. And in this regression equation, this epsilon can never be equal to 0 in a practical scenario. The epsilon will always contain some positive value. We all know that, right? Let us look at an example. So let us assume that there are two variables here considered for this example, advertisement cost and sales. Now, out of these two variables, which one is the effect and which one is the cause? So sales, as we all know, is the ultimate impact, right? So that will be your effect, and sales will be denoted by capital Y. And advertisement cost is the one which would actually trigger the sales. So this is one of the component which would actually trigger the sales. So the advertisement cost can be your X variable. That will be your cost variable, right? Say we have observed that the relationship between sales and advertisement cost is something like this. Sales is equal to 2 times the advertisement cost. So the relationship between sales and advertisement cost is something like this. Sales is equal to 2 times the advertisement cost. Now, for a given investment towards the advertisement cost, what will be the value of sales as per this equation? Suppose I'm investing $5 towards the advertisement cost. What will be my sales? Sales should be $10. If this relationship is true, then if I'm going to invest $5 towards advertisement cost, the sales will be exactly equal to 10. And if I'm going to invest $10 towards the advertisement cost, the sales will become 20. If I'm going to invest $15 towards the advertisement cost, the sales will become 30 and it will continue like this. And whatever values that I have actually calculated for sales, these are called as ideal values because I have considered this relationship and I have calculated the values for sales. That is, sales is equal to 2 times the advertisement cost, right? So I have considered this particular relationship and I have calculated all these values for sales, and hence they will be called as ideal values, right? But then we need to understand that the actual value for sales need not be exactly equal to the ideal value. So if you are going to invest $5 towards advertisement cost, we may not get exactly $10.000 as sales. So the sales could be somewhere around $10. Even if this relationship is true, the actual scenario, the practical scenario, the actual values for sales could be somewhere around 10. So it could be 9.8 or it could be even 10.1. Similarly, when we are investing $10 towards advertisement cost, the actual value for sales could be round about 20. It need not be exactly $20.000, right? It could be say 19.9 or it could be even 20.1, round about 20, even if this particular equation is true, right? So as we can see, for each and every instance of investment towards the advertisement cost, we can see that the actual value for sales is slightly varying from the ideal value. So this is how the practical scenario will actually look like. The actual value for sales would slightly vary from the ideal value, and this difference between the actual and the ideal values for sales is attributed due to common cost variation. So we cannot get a scenario wherein for each and every instance of investment towards the advertisement cost, we will get only the ideal values for sales. So that is practically not possible. In the practical scenario, the actual value for sales could be round about that ideal value, but may not be exactly equal to that ideal value. It can differ in decimals, right? So instead of exactly 10.00, it can be 10.01 or it can be 10.1. We do not know, right? So the actual value for sales may slightly differ from the ideal value. So that difference between the actual value and the ideal value for the y variable is what we would attribute due to common cost variation. And this clearly demonstrates that common cost variation can never be equal to zero in a practical scenario. So it will always contain some positive value. Clear? Fine. So having understood that common cost variation is inevitable, so it can never be equal to zero in a practical scenario, we will move further. So the next section, we are going to look at categories of metrics. So we are still in the introduction phase. We are getting some good introduction to all these, Six Sigma tools and techniques so that, when we are going to learn the actual concepts as part of the various phases in the DMIC approach, things will be very easy for us. So we are preparing ourselves to learn some of these advanced tools and techniques, which will be part of all these 5 phases. But then, as I told you, we'll keep everything very, very simple, right? So categories of metrics. What are the 3 categories of metrics? So the first one we have is nominal the better. So what is nominal the better? As the name itself suggests, these are the kind of matrices which are like too high is bad, too low is also bad. Should be somewhere in the middle. So nominal the better are the type of matrices which are like too high is bad, too low is also equally bad. It should be ideally somewhere in the middle. Say, for example, blood pressure, blood sugar. All these are nominal, the better kind of metric. Too high is bad, at the same time, too low is also equally bad. It should be somewhere in the middle, right? And for that matter, all these measurement dimension matrices like length, weight, breadth, diameter, width, right? All these are nominal, the better kind of metrics, right? So too high is bad, too low is also bad. It should be somewhere in the middle. The next we have higher the better kind of metric. So as the name itself suggests, all these matrices will always strive to achieve a higher value. Say for example, quality, accuracy, productivity, customer satisfaction, sales, revenue, profit. So all these matrices, if you see, these matrices will always strive to achieve a higher value, and hence it is called higher the better kind of metric. So higher the value, it is beneficial for us. But then there is a category called lower the better, which is exactly opposite to higher the better kind of metrics. So these are the metrics which would always strive to achieve a lesser value, possibly even zero. So all these matrices with a negative tinge will fall under this category, lower the better. Say for example, the number of defects, the number of customer complaints. So if you look at all these matrices, the value that we would want to achieve is possibly even zero, right? So these would fall under lower the better, or you can even include cost of poor quality, right? It is lower the better kind of metric. So these matrices would always try to achieve a lesser value, probably even zero, right? So these are the 3 categories of metrics that we have. So if you look at any of the metric that you would be measuring in your processes, so you can find out under which category that metric would actually fit in, whether it is nominal the better or higher the better or lower the better type. Now with this background, we'll also look at another important concept called specification limits. So what is this specification limit? And first and foremost, who provides this specification limits? So customers provide the specification limits. So why should customer provide the specification limits is the next question. Why? Because the customers also understand that common cost variation is inevitable in any process, in any system, and it is practically impossible for the manufacturer to produce each and every unit item measuring exactly the target value specified by the customer. So the customer is given the target measurement with regard to the length of the pen as 10 centimeters. So now that we have understood that common cost variation is inevitable in a practical scenario, is it practically possible for the manufacturer to produce each and every unit item measuring exactly 10 centimeters in length, like 10.000 centimeters in length? So it is practically not possible for the manufacturer to produce each and every unit of pen measuring exactly 10.0000 centimeters in length, right? So there will be obviously some variation in the measurement value with regard to each and every unit produced. So that is why the customer also would give what is called as specification limits. So the customer will not just provide the target measure, he will come up with these specification limits. He will say that the length of the pen should be 10 plus or minus 0.2 centimeters. So when he gives a specification limit like this, 10 plus or minus 0.2 centimeters, what does this actually indicate? It indicates that the target measure is 10 centimeters. The lower specification limit, which is also called as LSL, is 9.8 centimeters, which is 10 minus 0.2 centimeters. That will be 9.8 centimeters. And the upper specification limit, which is also called as USL, will be 10.2 centimeters, right? Which is 10 plus 0.2 centimeters. So if the manufacturer is going to produce a unit item measuring anywhere between 9.8 centimeters to 10.2 centimeters, the customer would be willing to accept that unit product as a conforming unit. Only if the measurement value is going to fall below 9.8 centimeters or above 10.2 centimeters, then the customer would be rejecting that unit product as a non-conforming unit or defect. Clear? Right? So if the measurement value for a particular unit product is going to fall within the specification limits, then the customer would be happy to accept that unit product as a conforming unit or an accurate unit. Only if the measurement value is going to fall outside the specification limits for a particular unit item, the customer would be forced to reject that unit item as a non-conforming unit or a defect, right? So that is what is clearly explained here. So we cannot expect the manufacturer to produce each and every unit item measuring exactly the target value. The target value is 10 centimeters. Then we cannot expect the manufacturer to produce each and every unit item measuring exactly 10.000 centimeters, right? So it is practically not possible because common cost variation is inevitable. So this the customer also understands very clearly. That is why the customer would provide the specification limits. Clear? This is very, very important because going forward we'll be solving statistical exercises with all these specification limits. So first and foremost, you need to understand why these specification limits are provided and who provides these specification limits as well, right? So for nominal the better, which of these specification limits will be applicable? So nominal the better, I had told you. Too high is bad, too low is also bad. Should be somewhere in the middle. So both USL and LSL will be applicable for nominal the better kind of metrics, right? Say for example, blood pressure. So what is the target measure that each and every one of us would strive to achieve? It will be 120/80. So that is the target measure each one of us would strive to achieve. Then what could be the USL and LSL for this blood pressure metric? So the USL could be 130/90, LSL could be 110/70. So if the measurement is going to be below 110/70, the person will be called as a low blood pressure patient. If the measure is going to be in excess of 130/90, the person will be called as high blood pressure patient. So for nominal, the better, as we can see, both USL and LSL will be applicable. So in this example that I have given to explain what exactly is the specification limit, so I have actually considered a nominal the better kind of metric. So length of a unit product, as I told you, is nominal the better kind of metric. So both the specification limits will be applicable for this metric category. Clear? And then we have higher the better. So higher the better, as I told you, all these matrices would strive to achieve a higher value. So there should not be any limit on the upper side, but definitely there should be a limit on the lower side of the data spectrum. So we will say that the target measure specified by the customer with regard to accuracy percentage is 99%, but the minimum service level is 97%. So what does this actually mean? Target that we need to achieve is 99%, but at any cost, we should not fall below the minimum service level of 97% specified by the customer. So this minimum service level is to be treated as lower specification limit. So if we happen to fall below this minimum service level, then we are liable to pay penalty to the customer. So those kind of clauses will be there as part of the agreement, right? Quite possible. So the customer will not only provide the target measure for higher the better kind of metric, the customer will also provide what is called as minimum service level, which needs to be considered as LSL or lower specification limit. So for higher the better kind of metric, there will not be any limit on the upper side, but there will be limit on the lower side, and hence only LSL will be applicable. And for lower the better is exactly the opposite. So these matrices will always try to achieve a lesser value, possibly even zero. So there is no limit on the lower side of the data spectrum, but there has to be a limit on the upper side of the data spectrum. So for lower the better kind of metrics, only USL will be applicable. So for lower the better, only USL will be applicable for these matrices. Clear? The applicability of the specification limits with respect to the three categories of metrics. Nominal the better, both USL and LSL will be applicable. Higher the better, only LSL will be applicable. And lower the better, only USL will be applicable. And then we move on to the twin objectives of Six Sigma. So we saw this briefly when we discussed about the concept of variation. So these are the twin objectives that we will strive to achieve whenever we work on a Six Sigma project exercise. So what are these objectives? The first objective is align mean with the target. So when I say align mean with the target, mean is nothing but the metric indicating the average performance, right? So mean is the metric indicating the average performance of a process. So when I say align mean with the target, it means we need to meet the customer target. Our average performance will have to meet the customer target. So that is the first objective. Say even in this example that we saw with regard to the length of a unit product. So we say that the target measure is 10 centimeters. So even though the individual, measure of that unit items may actually vary, it will be in and around 10. But if you take the average of all these measurement values, then it should ideally align with the customer target of 10 centimeters, right? So even though the individual unit measures could be in and around 10 centimeters, but then if you take the average of all these measurement values, it should align with the customer target of 10 centimeters. So that is the first objective of Six Sigma. When I say align mean with the target, once again I repeat, mean is a metric which would indicate the average performance of a process. So we will learn about all these statistical matrices as part of the measure phase, right? So for now, understand that mean is a measure indicating the average performance. When I say align mean with the target, it means align the average performance of the process with that of the target measure specified by the customer. And the second objective, which is equally important, is reduce variation. We are not looking at eliminating the variation because we know that common cause variation is inevitable. It cannot be totally eliminated. So that is why the second objective says reduce variation. So what do you mean by reduce variation? Now, having improved my process performance so that the average performance is aligned with the customer target, we need to ensure that we consistently perform around that improved performance levels. So that is also equally important. So in a Six Sigma project, we will strive to improve the process performance. So having improved our process performance, we need to be consistently performing around that improved level. So that is also equally important as part of our Six Sigma initiative. As I told you, so there is no point in, achieving the improved levels if you are not able to sustain it forever. So if the improved levels are seen only for say couple of months, after the project gets over, and the third month or in the fourth month, we again slide back to the baseline scenario, then you have not addressed the variation part as part of your Six Sigma project. So if you are able to reduce the variation, that means you should have been able to improve the consistencies in the process performance. So here we are talking about the consistency in the improved process performance. So that is the final objective. So at the end of the Six Sigma project, you would have improved the process performance. But we also need to ensure that we consistently perform around the improved levels. So that is what is called as reduced variation. So variation is an evil. It is exactly opposite to consistency. Variation means inconsistent, right? So that has to be reduced. So when I say reduce, the variation means we are improving the consistency in the process performance. So at the end of the project exercise, we would have improved the process. So we are talking about maintaining the consistency in the improved process performance. So these are the twin objectives that we have in Six Sigma. Since reduced variation is one of the key objectives of a Six Sigma project, we are even learning the subject called statistics because statistics is regarded as science of variation. And finally, we will also look at the twin methodologies that we have in Six Sigma. So what are the twin methodologies that we have in Six Sigma? One is the famous methodology called the DMIC methodology: define, measure, analyze, improve, and control. So this methodology is to be applied for improving the existing process performance. So you have a process which has been in existence for the last couple of years or for the last 3 years, and you want to improve this existing process performance, then we will use this DMIC methodology to improve the existing process performance. And there is yet another methodology called DMA-DV methodology. So here again, D stands for define, M for measure, A for analyze, and then the second D stands for design and validate. So this methodology, as we can understand, will be used for improving newly designed processes. So you're coming up with a new process design and you want the process to perform at higher levels of efficiency. So we need to apply this DMA-DV methodology to improve the newly designed process performance, right? But since we will be having an existing process and we'll be looking at improving the existing process performance, for most of the scenarios, we will be applying this DMIC methodology and hence this is a popular Six Sigma methodology. In fact, our curriculum is based on this DMAIC methodology, not the DMATV methodology. But then as a black belt, you need to know that there are two methodologies in Six Sigma, and when to apply these two methodologies also is something that you are supposed to know, right? So this is what it is. So tomorrow we will actually step into the first phase in the DMAIC approach, which is the define phase, right? So with this, we actually come to the end of the introduction phase. So tomorrow we will be stepping into the first phase in the DMAIC approach, which is the define phase, right? So let us do a quick revision of whatever we have seen so far in this introduction phase. So we started with understanding the traditional and the modern day definition of quality. So the traditional definition focuses only on the customer's interest. The modern day definition focuses both on customer as well as the service provider or manufacturer's interest. And we also understood what is cost of poor quality and cost of good quality. So cost of poor quality is the cost incurred due to process inefficiencies, whereas cost of good quality is the cost that we would incur to improve the process efficiencies. And we also looked at some of the important quality terminologies. Before that, we even looked at the dimensions of the overall quality. So if capital Q represents the overall quality, then the various dimensions could be the price of the product or service, the cost of operations, the timely delivery of the product or service, the accuracy of the product or service, and then the morale and the safety of the workforce, right? So all these are pretty much interlinked. So if you are having or if you're addressing the safety concerns of the workforce, then the morale of the workforce is bound to be pretty high. And if the morale of the workforce is high, the workforce will be able to, produce the product with lesser errors or lesser number of defects. And they will also be able to deliver the unit product in a timely manner to the customer. So if the timely delivery and accuracy is taken care of, then we will be able to reduce the cost of operations. If the cost of operations gets reduced, then we will be able to quote a competitive price for my product. So all these dimensions are pretty much interlinked. So then we saw some of the important terminologies in quality control and quality assurance. So QC are the set of activities that we will perform at the output stage of a process. So this is basically carried out to validate whether the output adheres to the customer specifications or not. So quality inspection at the output stage is a quality control type of an activity, and this is a reactive activity. Whereas quality assurance QA or the set of activities we will perform during the input and the processing stage of a process so as to assure that the process would deliver error-free output. And this QA would be typically a proactive type of activity, right? So the risk identification, the process improvements which we would perform, all would come under the QA set of activities. And then we also looked at CAPA. So there are three stages here: correction, corrective action, and preventive action. So correction is something that we will do immediately after identifying a defect or a damage. Corrective action, the set of activities that we will implement in order to prevent the reoccurrence of an error or a damage. And then the preventive action or the set of activities we will implement in order to prevent the occurrence of a defect or a damage in the first place. So preventive actions are like your control measures or the POK-OK measures, which you would implement after identifying the risk in the operations. And then we also understood what is cause and effect. So effect is the ultimate impact that would be experienced due to a single cause or multiple causes. An effect cannot happen in silo. So this will always be driven by a single cause or multiple causes. So that is why effect will be referred as a dependent variable and cause will be referred as an independent variable. So if you are going to directly attack the effect, we'll get only a temporary solution. So if you want a permanent solution, then we need to identify and attack the root causes for the effect. And in Six Sigma, effect is denoted by capital Y, cause is denoted by capital X. Then we looked at the three commonly used process improvement methodologies. So Kaizen are small and continuous process improvements which can be carried out by an individual employee who could even be at the ground level of an organization hierarchy. Then Lean as a process improvement methodology is a philosophy which is about creating perfect value to the customer through a process with zero waste. And Six Sigma is a breakthrough process improvement methodology, which should ideally result in significant dollar savings for the practicing organization. But then how to identify whether a process improvement initiative is Kaizen or a Lean or Six Sigma, we need to consider causes and solution. Causes are known, solution is simple, we call that as Kaizen. Causes are known, solution is complex, we will call that as Lean. Causes are unknown, the solution is simple, we will ask an expert. Causes are unknown, solution is complex, we will call that initiative as Six Sigma. So we could understand why Lean would focus on attacking the known causes, Six Sigma would focus on exploring the unknown causes, make it known, and finally attack the same with relevant solutions. So whenever we have a business problem, we would first, try to attack all these known causes before venturing into exploring the unknown causes. So Lean would be an integral part of our Six Sigma journey. So Lean as a process improvement will always precede Six Sigma. So that is why the Six Sigma projects will also be referred as Lean Six Sigma projects. So hence we looked at the basics of Lean at a very high level. So we understood that Lean originated in Japan, specifically in Toyota production system. So we also looked at how Lean evolved in Toyota production system. So Lean, as we know, is all about identifying the ways which are typically the NVAs in the process. So thereby, helping us to execute the process within a shorter time frame. So the primary objective in any Lean initiative will be to reduce the overall time taken to execute the process. So what is the NVA? NVA are typically those activities which do not add any value to the output in terms of shape, size, or quality. So we also understood that waste is of three forms. Muda is the pure waste that we can identify in a process. And Mura is the variability or inconsistency in the way the process is executed. And Muri is the overburden or stress. Similarly, NVAs are of two types, pure NVA that we can identify in a process chain, and the essential NVA are value enablers, typically the activities performed by the support functions. So in a lean project, what is that we will try to achieve? So we will try to maximize the value added activities, minimize the essential non-value added activities or value enablers, and look at eliminating the pure non-value added activities. And then we looked at the 5 principles of lean. The first principle is understand the value expected by the customer. The second principle is map the value stream. The third principle is establish flow. The fourth principle is implement pull. So the implement pull can also be the customer demand, as I told you. So we need to produce as per the demand expected by the customer or demand placed by the customer. So the customer demand or the customer target can also, function like a pull mechanism for the process to, function effectively and efficiently. So this basically would help us to, avoid multiple ways, right? So if it is kind of executed by the downstream processor, it would help us to avoid the waiting time waste. So if you are able to, understand the pull mechanism indicated by the customer when he is going to place the demand for your product, we will be able to minimize the inventory type of waste. And then finally, we have work to perfection. So this is the stage wherein we will identify the NVAs in the process chain and look at eliminating it. And we also looked at the 7+1 types of waste. So I told you that if you can remember the acronym called DIMEWAT, you will be able to list down all the 7 types of waste. So defects, inventory, motion, extra processing, waiting, overproduction and transportation. And the eighth waste is case waste, which is knowledge, skill and ability waste. And we also looked at the prominent lean tools. So the first one is VSM, value stream mapping, which is a type of a process flow, which would help us to map not only the material flow, but also the information flow, right? So VSM will also, help us to track some of the key matrices for all these milestone activities like volume inflow, number of backlogs, number of defects, processing time, as well as the waiting time in between the two activities. So hence VSM can be treated as a diagnostic tool which would help us to identify the waste hidden in a process or a system. And then we looked at 5S plus 1S, which is practiced in order to maintain an orderly workplace to boost productive work environment. In fact, this is the first activity that we would perform in a lean project. So the 5S's are sort, set in order, shine, standardize and sustain. And the plus 1S is safety. Then we have POK, which is also called as mistake proofing. So these are nothing but the preventive measures or the control measures that we would implement post identifying a risk. So the repercussion is not all that serious. We would implement a warning POK. If the repercussion due to any deviation is slightly serious, then we will implement prevention POK. If the repercussion due to any deviation is going to be very, very serious, it can result in significant damage, then we will implement shutdown POK. So these are the three levels that we have in mistake proofing or POK. And then we looked at Jidoka, which is not a simple automation. This is an automation with the human logic or human intelligence. So this is also called as automation. And then Kanban is typically a dashboard kind of a tool which would help us to understand the status of each and every activity practiced in a process chain. So Kanban with just-in-time concept would help us to reduce or eliminate the inventory type of waste. And then standardization is all about executing the process in a standard manner so that the output delivered by the process is also highly consistent. So standardization will help us to eliminate or minimize the Mura form of waste. Then finally, we looked at Haijunka, which is whole load leveling. It is all about distributing the workload equally amongst the team members or stressed. So Haijunka, practicing Haijunka will help us to eliminate or reduce the Muri form of waste. And then we looked at the prominent lean metrics. The cycle time is nothing but the processing time of each and every activity in the process chain plus the waiting time between the two activities. Whereas the lead time is the cycle time plus the preparatory time at the beginning of the process plus the waiting time or the time taken at the end of the process before the output is delivered to the customer. And then we also have the tag time, which is the ideal time that should be taken to produce a unit item in order to meet the customer demand. So the tag time logic can be used for estimating the number of employees required for working in a particular process. So given the customer demand. And then we got introduced to Six Sigma. So Six Sigma was introduced by Will Smith and Michael Harry of Motorola. So we also understood as to how Six Sigma became famous throughout the entire world. And even though Motorola introduced the Six Sigma methodology, as I told you, it was General Electric, which actually adopted this methodology with lots of passion and interest. And they also reaped very high financial benefits. At Six Sigma level, so Sigma level would indicate the process efficiency or quality level. So at Six Sigma level, which is supposed to be the world-class level, a process would contribute just 3.4 defects per million opportunities. In terms of process efficiency, this would work out to 99.99966% process efficiency. And there are three facets of Six Sigma. So as we know, it is a process improvement methodology. It is a benchmark metric. It is a philosophy. Why Six Sigma is called as a philosophy? Because Six Sigma strongly advocates identifying and attacking the root causes to improve the effect. This sounds philosophical, like do your duty, the result will happen on its own. And then we looked at the concept of variation, which is a very important component in a Six Sigma curriculum. So variation simply defined as any deviation from the standard. But if you are dealing with a set of measurement values, then the variation will be the differences in the measurement values in a data set. So we learned statistics as part of our Six Sigma curriculum because statistics is regarded as science of variation. So we also understood about the types of variation, common cause or chance cause variation, and assignable or special cause variation. So common cause variation are the minor variation that we would observe in a process performance for which we will not be able to assign any reason immediately. So this common cause variation, as we could understand, is inevitable in any process, in any system, and it cannot be totally eliminated. We can only reduce this common cause variation, that too through Six Sigma efforts. Whereas assignable cause or special cause variation are huge variation that you would find in the process performance, for which we will be able to assign a reason immediately. If this assignable cause is well within our control, we can even look at eliminating the same. So common cause variation, as we can see, is all about exploring the unknown causes and looking at attacking the same in order to reduce it. Whereas assignable cause is a scenario where the cause is known to us. We don't have to really perform any extensive data analysis to identify that cause. The cause will be pretty much known to us and we will straight away go ahead and attack the same. So addressing this common cause is what we would do in a Six Sigma project. But if you are attacking the assignable cause, that is exactly what we would do in a lean project. So lean is about attacking the known cause. Six Sigma is all about exploring the unknown cause, making it known, and then finally attacking the same. So we also understood what exactly is common cause, what is an assignable cause through a very simple example. And we also kind of understood that common cause variation is inevitable in any process, in any system, through another example, right? Wherein we considered the two variables as sales and advertisement cost. And we could understand that given the relationship between the sales and the advertisement cost, we will not get all ideal values for sales in a practical scenario. So in a practical scenario, the actual value for sales could be slightly differing from the ideal value, and that difference is attributed due to common cause variation. And then we looked at the three categories of metrics. Nominal the better, or the type of matrices which are like too high is bad, too low is also bad. It should be somewhere in the middle. So for example, blood pressure, blood sugar, and any measurement dimension metric will fall under nominal the better category. Then we have higher the better. So these are the matrices which would always strive to achieve a higher value, right? Say for example, accuracy, productivity, quality, customer satisfaction, sales, revenue, profit, all these are higher the better kind of metrics. And then we have lower the better. So these are the matrices which will always strive to achieve a lesser value, possibly even zero. For example, the number of defects, the number of customer complaints, the cost of poor quality, all these would fall under lower the better category. And then we also looked at the concept of specification limits. So who provides the specification limits? Customer will provide the specification limits. So why should customer provide this specification limit? Because customer also understands that common cause variation is inevitable in any process, in any system, and it is practically impossible for the manufacturer to produce each and every unit item measuring exactly the target value, right? Hence, the customer would provide the specification limits. So if it is nominal, the better kind of metric, we will have both USL and LSL applicable. So if you are going to produce each and every unit item measuring anywhere between the LSL and USL values, then the customer will be willing to accept that unit product as conforming unit. Only if the unit measurement value is going to fall outside the specification limits, then the customer will be forced to reject that unit item as non-conforming unit or a defect. Whereas for higher the better, we will have only the lowest specification limit which will be applicable, and for lower the better is exactly the opposite. We will have only the upper specification limit which will be applicable. And then we also looked at the twin objectives of Six Sigma. So what are the twin objectives of Six Sigma? The first objective is to align mean with the target. So when I say align mean with the target, we need to ensure that our average process performance aligns with the target measure specified by the customer. So this is very, very important. So the individual measure could be round about the target measure. But then if you take the average of all these individual measurement values, then the average measure should align with the target measure specified by the customer. So that is the first objective of Six Sigma, which is align mean with the target. And the next objective was reduce variation. Now, having improved my process performance so that the average performance is aligning with the target measure specified by the customer, I need to ensure that I consistently perform at these improved levels, right? And that is what is reduce variation. So again, we are not saying eliminate variation because we know that common cause variation cannot be totally eliminated. It can only be minimized through Six Sigma efforts. So here, reduce variation as an objective refers to reducing the common cause variation. Because as part of our Lean initiative, we would have addressed all these assignable cost variation. So in a Six Sigma project, we will only address the common cause variation. So we will look at reducing the common cause variation. So that is what is written here. So having improved the process performance, we also need to ensure that we are consistently performing at the improved levels. And then finally, as part of the introduction phase, we also looked at the twin methodologies that we have in Six Sigma. The first, the famous methodology that we have is DMIC methodology. So define, measure, analyze, improve, and control. So this methodology will be applied for improving the existing process performance. So you have a process which has been in existence for say a couple of years or so. And if you want to improve the process efficiency, in that case, I need to apply this DMIC methodology to improve the process efficiency. The other methodology that we have in Six Sigma is DMA-DV methodology. Again, define, measure, analyze, design, and validate. So this methodology, as we can see, will be applied for improving newly designed processes. So if you are coming up with a new process design and you want to improve the process performance, right, straight away, then in that case, we need to apply this DMA-DV methodology. And as I told you, our curriculum is based on the DMIC methodology. So as part of the DMIC methodology, we will be stepping into the define phase tomorrow. And we're looking at the deliverables that are part of the define phase. And then we will look at the measure phase, analyze, improve, and control phases in that order, right? So measure phase is where we will start working on the statistical exercises. So when we step into the measure phase, I will also send you the link for downloading the trial version of the Minitab software. So as I told you yesterday, so it'll be, solving all these statistical problems by applying the Excel formula as well as the manual formula. And we will also use a statistical software called Minitab. So the trial version of this Minitab software is a free download. So I will send you the link for downloading this free trial version of the Minitab software. But then it is not mandatory. So if you're not able to download, it's absolutely fine. We'll be able to manage with all these Excel formula and the templates, right? It will not be a showstopper for us, but you can always learn how to solve these problems using Minitab, right? So that will be from the measure phase onwards. So tomorrow, I will not only send the first set of quiz questions, right, pertaining to the portions that we would cover in the first 3 days, but I will also send you the link for downloading the free trial version of Minitab software. So during the weekend, you can just try out and see. So if possible, you can just download it. If it is not possible, no worries. We will be able to manage, right? So let us stop here. So we will step into the define phase tomorrow. So have a good night and we will connect at the same time tomorrow evening. So thanks for your time today.
Good night, sir.
Good night.
Good night.
Thank you.
Thank you.
Good night.